Great. And we're back for day 3, the final day of the computational law cocktail party hour, I guess, is what's going on, more or less. So, cheers. So today, what's going to happen is, well, first of all, what happened after we went off air, those of you on Telegram would know, is that we broke into small groups and worked on several use cases. We were able to identify the actors and the actions. In some cases, we got as far as some swim lane diagrams on use cases that involve, various various takes on supply chains, and then also on microgrids or on energy. And so we'll be coming back today to maybe take forward some of those use cases, or possibly generate some new ones, or combine and separate them. And we're joined by our friends and colleagues at Thomson Reuters Labs. And Brian Ulesny is going to walk us through some interesting tools that we may choose to use. So today's about rules and tools, you could say. And we'll get started with Brian. We'll get started with Brian and team walk us through those tools, and then we'll go around the table and online to Telegram to see if anyone has a use case that they would like to work on. We'll give people an opportunity to break into teams, and I think if we have, and we'll have to figure out whether we have enough people on Telegram to do an online team, or to maybe set up a hangout for them and maybe a HackMD file. Or if we have some real ringers and people with expertise online that can augment a team in the room, or vice versa. So we'll get there. But first things first, and I guess I can't say enough about this. As instructor and also our teacher's assistants, we're honored today by our Defense Logistics Agency participants with this merit coin for excellence, and we couldn't be more grateful for this. So thank you. And we're very, very glad to have you there. All right, so Brian, do you have the magic technology?
I do.
Okay, let's hit it.
Okay. So thanks. I'm here with Amit Shavit from the labs.
Yeah, sure.
Oh, sorry.
Can you send me a hangout link as well?
Will do.
Yeah.
Okay, we're just switching our mutes.
Okay. I should be audible now.
Yes, you're good.
All right, so I'm here with Amit Shavit, also from the TR Lab Boston, and Shreya and Jane, our extern for January. And we are one of 7 global labs within TR. And our focus isn't particularly around blockchain type issues, but thankfully we have colleagues in our Swiss lab outside of Zurich in Bar, Switzerland, who do focus a lot on blockchain stuff. And so they've been helping us out this morning, getting some very simple smart contracts going on the TR test blockchain that we, so yesterday we set up wallets on the blockchain and practiced sending little bits of ether to one another, and now we've got a little smart contract going that Amit will show you later, and that basically it does something really simple, which is it figures out which is the larger of 2 bids for some unspecified good and returns the larger bid. So right now, what I wanted to just show you is I'm not going to go through all the slides. I'll get into the tools more quickly. Thomson Reuters' primary mission is to provide information and data to professionals who need it. So we have a big business in the finance and risk space, tax and accounting space. We used to have a big business in the IP and science. We sell patent data and trademark data and so on, but we spun that off.
Clarivate?
Clarivate. So Clarivate is the former TR IP and Science division. So here's, for example, so here's a firm called Boehringer Ingelheim, which is a big Swiss pharmaceutical company. And so just to give you a sense of the kinds of, the amounts of information we have, 48,000 pieces of news and broker research and thing that's so on in the financial realm, 16,000 some legal documents about the legal status in law cases and so on, 180 pieces of tax analysis and so on. So one of the things that we've been doing in TR lately is taking, so all, we have this data and it's grown by acquisition, and we have these silos of data and these that we serve, and we've been creating this giant knowledge graph out of these things. So we want to identify the connections between entities in all of the data that we have. And so we sell the TR knowledge graph, which consists of tens of billions of edges connecting entities at a very fine-grained and curated level, and certain kinds of relationships between those entities. So subsidiary relationships, for example. So knowing the corporate hierarchy is very important. We maintain those relationships. So-and-so is sued by some other company. That's a relationship that's maintained. Quotes and instruments and all of these kinds of different entities are related in this knowledge graph. And then there are tools then that allow you to extend the knowledge graph with additional data. And then you can do graph analytics and so on. One of the interesting, well, I'll get to that actually. So here's an example of, just a small piece of the knowledge graph relating, so there's a company named Thomson Reuters, and it makes a product called Icon, and there's a patent that applies to that product, and the quote for the company is related to this instrument on the Toronto Exchange, and so on. So we got guys in wigs. When you have tabular data, it's important, especially if your whole business is selling data, to make sure that the data is accurate and so on. But basically, the inaccuracies in tabular data is a little more confined to the actual row of data, whereas in a graph, inaccuracies affect all of the analytics that you're doing over that graph. So if some analytic that you're doing on the graph depends on accurately, counting links, the distance in the path between some entity and some other entity, or the betweenness of something. So how many paths between things cross through a certain node. If that node or those links are incorrect, then that's going to throw off all of your graph analysis. So it's very important to have accurate, nodes and edge representations. And so I like to think that these are governed by two laws around node identity. So one comes from Bishop Butler, an 18th century philosopher, who says, everything is what it is and not another thing. So if anything that an identifier should only denote one thing, it shouldn't be ambiguous. It shouldn't be able to denote two things that are not themselves identical. Principle is Leibniz's law, the indiscernibility of identicals, that says if two things are identical, then they have all and only the same properties. And basically, these two principles give you a very strong have very strong consequences for how you build a knowledge graph. So here's a graphical depiction of Butler's maxim that you can't have a URI denoting two things that are not in fact identical. And if Z bears property Q to this URI, and it's identical to URI2, then these things, then Z must bear relationship Q to URI2, and so on, if they're identical. All right, so this leads you then to a couple candidates for what you might use as an identifier for organizations, for example. And so one is the Reuters instrument code, or a RIC, which is basically that's the combination of the ticker symbol for a company, plot, and then a dot, and then the exchange. And that's, for a long time, Reuters used that as the sort of standard identifier for organizations. The problem is that ticker symbols change over time. So, for example, the symbol C used to denote Chrysler, and now it denotes Citibank. So if you're, data munging and data analytics on a database, and you don't realize that the symbol C dot MY or whatever for the New York Stock Exchange, that changed reference at a certain period in time, then that's going to probably have an effect on your analytics. DBpedia URLs have multiple URIs for the same entity. Duns numbers are nice and quite familiar, but Duns numbers are, for one, not public, they're private. So you can't always determine the Duns number for an entity. Generally, for government, if something has a government contract, then they are required to denote their Duns number. But a Duns number also is location specific, so it's sort of at a more fine-grained level than the legal entity that we're sort of interested in. Website URIs might be a good idea, but they're sort of, they can change over time and are sort of ambiguous. So it's difficult to express, for example, that Fiat SPA and Fiat Investments NV merged using website URIs, because some of those don't really have their own distinct URI for the website URL. And tax identifiers are not generally public. So we suggest then the using. Yep.
If the authoritative source of existence and name for a legal entity, like a corporation, LLC, not sole proprietor, say, but type of companies that you're talking about, are in the United States the Secretary of State's office, where you're incorporated and where you have a unique name in that jurisdiction, and then the equivalent office in other countries. Just like a common sense, obvious question you should probably address before we get into LEyes and some of the other stuff would be, why not the unique common name, like General Electric, Inc., like -NY, -US or something, so that because there are sometimes the same name across different states. So why not that? We just address it.
I think those can be. It's possible to have the same common name in the same jurisdiction, right? But
so that's like number one, now for disambiguation and analytics. And I think you had me at number one. Number two, though, would be like what a computable. May they change would be another one.
Right.
You can have the same name even in jurisdictions like Massachusetts where you're not supposed to have the same name. At the same time, you can have the same name after some respectful period of mourning, I guess, for the old company. And then and the other thing is, just as a matter of a unique string, you can do a lot better. Like when you kind of know something like the first 4 digits designate this, and the next 4, if you're doing regex or some kind of analytics or processing, the name can contain a lot of information when it's a string as an identifier. and there's something inextricable, I'm sure we'll get to in our projects, but identity, you know, includes names, common names, identifiers, and also like, you know, roles and context, like a duly constituted New York company of whatever. So like there's many facets of you know, like identity, and you're looking really at the identifier, I think.
Well, we're looking at the identifier as a way to unambiguously denote entities, and a system of identifiers where the denotation of a thing won't change over time.
So you're looking for that like globally unique, globally unique static identifier. That's that identifier, like the serial number identifier.
Right.
Okay. So everyone, does that make sense to everyone?
Yeah, it does, but you're also looking at the relationship between the abilities based
Right.
on those identifiers.
Right. Right. So the thing that, if something becomes a subsidiary, we don't then assign it the identifier associated with the parent. It still maintains its identity, and we assert that it has this relationship then to its parent.
Great, thank you. I just want to make sure everyone's on board.
Sure.
Especially those of us who are technical and not necessarily so legal. So carry on.
Okay, so here's an interface that people might find useful. So you can go to permid.org. You can search for companies. So here's Thomson Reuters. So there's several for which the name Thomson Reuters matches. Thomson Reuters Corp, Thomson Reuters US LLC, Thomson Reuters US Holdings Inc., Thomson Reuters Markets KK. These are all distinct legal entities. This is actually the parent here. And so we provide this lookup. We've got this Perm ID. This Perm ID will only ever denote this legal entity. That entity might go out of business. It might merge with something, but it will only ever denote that. You get various kinds of information. Is it a public company? Is it active? Yes. When did it IPO? When was it incorporated? We've got links to the Thomson Reuters business classification at various levels. So at the top level, it's an industrial. At the more specific level, it's a professional and commercial service. It's domiciled in Canada and incorporated in Canada. It's got a link to a website, and it's got a link to an LEI. And then we've also got the officers and directors of the company, and so on. And
I forgot how great this was.
Links to the instruments and the RIC, and so on and so on, and so forth. So all of these things, this data, you can download this data just for free by registering at this site. And the data is refreshed sometimes multiple times per day. So there's a whole team of people whose full-time job is curating this data set. There's around 3.5 million organizations. I'm not sure how many officers and directors, but there's got to be an order of magnitude more officers and directors, and so on. So you can the bulk download is here, and then of course you can tie that to the LEI. Let me just show you that you can look things up in various ways. So if I copy the LEI that we talked about yesterday, the legal entity identifier, I can go back to entity search, look this up by LEI, and I get one and only Thomson Reuters Corp. Same thing I was looking at. All of these things have a dereferenceable URI, so you can use this within your sort of semantic web type applications and dereference it to get the information. And I'll show you what this looks like in terms of, so you can get this in Turtle or JSON LD. And so here's the Turtle response. So it references various ontologies that it's getting these relationships from. Okay, so this is the system of identifiers. At basic level, we have, for organizations around 3.5 million companies that we track. They're linked to LEyes. LEyes are, you have to apply for an LEI yourself. You have to determine that you want an LEI. LEIs are required, as we said yesterday, if you're going to do a MiFID compliant trade. So if we're going to trade derivatives, for example, those fall under the MiFID II regulation, which requires that both parties have a LEI assigned to them. So that's some impetus for getting an LEI. And that rule went into force on January 3rd of this year, so just 2 weeks ago. But there's still only about, I believe, somewhere around 600,000 LEIs in the world, whereas we have 3.5 million organizational Perm IDs that link to the LEIs. So a slightly bigger universe for Perm ID than LEIs. Let me just show you then, we also have also for free, and this is just the demo thing here, but there's a tagging tool that we have called Thomson Reuters Intelligent Tagging, or it used to be known as Open Calais. Let me just get the, oh yeah, let's just go to the service of Block 1 ID that we were using yesterday. Okay, so I'm just going to copy this license agreement, which is, essentially a contract, and paste it into the tagging tool. I'll say tag it. Okay, so it finds various entities. So it finds, for example, Thomson Reuters US LLC. So remember, that was a distinct legal entity from the Thomson Reuters Corporation. It's got its Perm ID that I can then find further information about. It says that this document is 80% about this legal entity. It's got various kinds of relationships. So an acquisition, there's an acquisition between the WCGV licensee LLC and Thomson Reuters. Various quotations and so on. And then interestingly, it's got some, wow, these are kind of strange. Industries and social tags. Okay, so it realizes that this is a software license, for example, and the royalty payments are involved, that there's some kind of economic activity here. It also assigns it to some other topics, some of which are not super relevant here, but in general, it also has a relevance ranking, so some of these are considered low confidence. But anyway, so you can API. You can pass text in bulk through this. The free version is, of course, limited, but there's a paid service where you can. Yep.
Yeah, a question about the organizational detail. Is that something that is input in by the company, or is that compiled by TR?
It's compiled by TR. Well, and so, sometimes we'll just, if a company, for example, registers in a location that requires the company to disclose this, and it's easy, and the most convenient thing for us is to just import that data and and put it into our format, then we'll do that. But in some jurisdictions, we take that burden on for our customers.
So I looked at two companies, Boeing, there was a lot of detail in there, whereas Lockheed Martin Aerospace didn't have much.
Really?
So
that's a little surprising.
Or maybe I did my search wrong, but just for that particular organization that I found,
Mm-hmm.
it was mostly NA and.
Oh.
Yeah.
Maybe you didn't get. Maybe there's several or did you say Lockheed?
Lockheed Martin.
Yeah.
Yeah.
Maybe there are more than one Lockheed, and you're looking at a different one. I just wanted to point out here that you can mark. This comes back as marked up HTML in this interface, but you can download this. You can get the output of the intelligent tagging as RDF, which then is graph shaped. And for example, you can do Sparkle queries over that RDF graph to do some interesting things. So last year we were doing a little with DASA on contract analytics. So we took a lot of terms and services from online services like Dropbox and what were some of the other ones? AWS,
bunch of standard.
Salesforce.
Right.
So we took those things, and then we wanted to identify, for example, what is the governing law, jurisdiction for these contracts. And so you can write some Sparkle queries then that say, find me a Thomson Reuters country, something that's identified, but that would be identified in Calais as a country or a state, and then do some pattern matching for the text. The governing law of is such and such, or this contract is governed by the laws of whatever, and then it was easy enough to pull out the governing jurisdiction for these various contracts using this tool.
And then we displayed them on a map, and it's another like simple kind of sort filter search, and it's very nice hack. It's one of those. It's the kind of collaboration is why I love working with Thomson Reuters Labs, because when it takes a fundamentally legal question, because let's say you're a line op, you're a person who needs to figure out GDPR is coming. Do I have contracts that would be covered by that? You have services like a CIO question that would be covered, that would be subject to that law. Well, so I don't know. That wasn't the question that we asked. That we were like, there's not like a spreadsheet with that already. It's a new question. How do you know? So we had to look at the available data and think through in that context. How would you present the data? Well, math would be one way, and then we did a little bit of sort filter search, and the whole thing was like 2 or 3 days or something.
Yeah, 2 days.
Or the fractions of people's time, and they showed it at the first legal analytics American Bar Association big meeting too. So it's and so there you can too hack the law, and then we can do it again today in a whole new way.
Cool. So just to give some time to other organizations as well. So here's this comes from some company called Mako Labs, I believe. Provides a service called LEI.info, where they're taking the GLIFE, the global LEI registry. They're taking that data, and they've also created an RDF or semantic web type interface to that. So you can also search for Thomson Reuters Corp and get this, and then get an RDF-based representation of the company. Has an LEI profiling service that allows you to, since you've got, there's no legal MiFID compliant trade that doesn't involve LEI registered entities. So this allows you, we have an LEI profiling service that says, here's all the people I'm going to trade with today. Can you guarantee that they all have current LEIs? I just wanted to show you that the Perm ID system allows you to query various data sets and across data sets. So you can, for example, query Wikidata. So this query is saying, give me the logo for the company that has this Perm ID, which turns out to be fiat, and this query will then return you the this file, which is the fiat logo. So there's various ways then to use this to do sort of fine-grained querying across different data sets. I showed you Open Perm ID. And I showed you that. I showed you TRIT. That's the Calais output, confidence metrics. Okay, so there's that. Then before we turn to the smart contracts, I just wanted to talk a little bit about how you might use this in various ways. So if you're a compliance officer at a company, for example, you've got to assess the risk of that the people you're partnering with are going to comply with various regulations. So one of which is, for example, there's the UK Modern Slavery Act, and there's executive orders in the US that for DoD contractors, for example, that they can't have any forced labor within their supply chain, or they're excluded from contracts. So we did a project with, oops, I'm going the wrong direction, that's why. We did a project with our partners in the UK risk division of TR, where the challenge was, can we take all of the information that we know about companies, so news data, legal cases, risk data, financial data, geographic data, tax data about companies, and can we figure out and assign a risk profile to that company as to whether they are likely to run afoul of both the UK Modern Slavery Act and similar legislation in the California Supply Chain Act, US executive orders on forced labor, and so on. There's similar legislation that's pending in the Netherlands and Australia. And the other thing that we looked at was bribery and corruption risk. So what's the likelihood that a company that you're going to onboard as a partner or supplier runs afoul of the Foreign Corrupt Practices Act? So where you're responsible for what your suppliers do. For example, if they're bribing people, then that can result in a substantial penalty to you. So we took a risk-based policy where we wanted to understand where the red flags were in supply chains and be able to do ongoing monitoring. Oops, again, I'm going the wrong way. So most of the time this is done currently through Google searches and researches and so on. We incorporated as one of the data sets this Thomson Reuters country risk ranking, which incorporates into a single interface various risk metrics at the country level for compliance with the appearance in the trafficking in persons report from the State Department, for example. What's their level of ease of doing business, corruption indices, and so on. That was one of the data sets we incorporated. World Check data, which is data about perpetrators of financial crime of various kinds on the one hand, and politically exposed persons on the other hand. So politically exposed people who hold office or are related to people who hold office are in a position to do favors for companies. And so therefore, if you have a relationship with a politically exposed person, you're at increased bribery and corruption risk.
Oh my gosh, really?
Yeah.
People from Brazil can never make business.
Yeah, Brazil's got a slight problem there.
Wow.
We used the Thomson Reuters value chain data set. So this is an interesting extension of the knowledge graph that I showed you. So what we did here was we mined filings of public companies and news and found evidence in text that company A is a supplier of company B, or that company B regularly buys things from company A. And if there were sufficient pieces of textual evidence for a customer-supplier relationship, then we add this to this value chain data set and assign a confidence measure to it. So we have over 250,000 pieces of the connections in the global supply chain that we've mined from these public sources this way. So this is, for example, related to Boeing.
Is it available publicly, or is that just in-house?
Yeah, it's available publicly, but it's not free.
Okay.
Yeah. The Perm ID stuff I showed you was all free.
Right.
The corporate hierarchies that use that are not free. Yeah.
Got it. Thanks.
Okay, so anyway, the bottom line here is that we were able then to score, because we could distinguish things by Perm IDs. We were able to distinguish legal entities by at this legal entity level and associate them with a unique identifier. We were able to aggregate this information around that identifier, find all the pieces of evidence that said a company was likely to be involved with forced labor in their supply chain or bribery and corruption, produce a risk score based on that, and we were able to score all 3.5 million companies with Perm IDs, for example. And then for companies that had already published like their top level suppliers, we were able to do then a distribution of the risk in their supply chain. So here's Apple has 149 suppliers that it published as part of it, the sort of reputational blowback to its problems with its supply chain in China. And so we scored all of those companies, and we were able to say, okay, so it's encouraging that bribery risk is red and slavery risk is blue. That the majority of their companies are low risk, but it's troubling that there are these companies that are high risk, and then you would want then to build into your contracts things that would mitigate that risk, ongoing monitoring, put into your contracts. You've got to guarantee that you're doing X, Y, and Z to risk that I've determined for your company.
Could I ask?
Yes.
First of all, this is impressive. I hadn't seen this before, and it's right on some of the things we've been brainstorming, supply chain stuff that could be relevant, human trafficking and source of goods and so forth. I'm wondering, is there any way to further validate this estimation of the low, medium, high risk grouping? Since you did it, have there been any, I don't know, has this tracked in the future to revelations, for example, of bribery or enforcement actions or anything like that?
Yeah, no. So that's an important thing, and the other problem here is that very few of these cases ever get either litigated or let alone convicted, right? So, yes, saying this company did end up in legal trouble, and we predicted they were high risk. That's an important thing.
Yeah.
But it's not guaranteed that all the bad guys are being prosecuted. In fact, we know to a large extent that the bad guys are not being. There's no legal consequences.
Right. For what it's worth, I was just thinking of like former person that was, at the time it felt like unenviable responsibility to negotiate and monitor a bunch of contracts with suppliers of big organizations. It makes me wonder too. When I was thinking validating revelations, I wasn't even necessarily thinking, but even like this one, is this Apple?
Yeah.
So like maybe people inside Apple who would then go out and do the site inspection or do, the various other forms of monitoring that they do, if this would possibly, in some way, could be validated just from from their internal business intelligence and other sectors. And the other thing I realized is, geez, if I was in such an organization, I would probably put a lot more like active intelligence on the high risk ones, and then guess what? I'd get a lot more evidence on the high risk ones, which would skew the validation. So I'm not really sure how you would validate these actually. Maybe that's a question for further research.
Yeah, exactly. Yeah,
but
so
it's very impressive, I'll say that.
Okay, thank you. So here, for example, we were there had been some email exchanges about Berry Amendment and Buy American prosecutions and so on. So
Berry Amendment.
Yeah, so very few legal actions around the Berry Amendment, right? But I forget.
Just a word on what is the Berry Amendment?
Oh yes.
Anybody?
Do you want to handle
Maybe
that?
you could, let's take the pressure off of our students.
All right.
And like you're the instructor, instruct. What's the Berry Amendment?
What's the Berry Amendment?
It is B-E-R-R-Y, not B-A-R-R-Y.
B-E-R-R-Y.
It's not Chuck Berry.
So let me.
It's not raspberry.
Well, does anyone want to volunteer who doesn't do this for a living? The Berry Amendment?
I would certainly commit like malpractice.
I can give you a brief overview. Essentially, it's a restriction on, we have to, in certain situations, source goods that are provided in the United States from domestic sources. So the Berry Amendment is one of the regulations, and a long list of types of regulations that require that. But for a number of exceptions, domestic sources like they need to be sourced from U.S. sources. So that's in short what the Berry Amendment.
So it ensures U.S. domestic origin for products and services or just products.
My understanding is it's just, I've only seen it in supplies, but
certainly products and supply chain from made in America.
right. Exactly.
And just a little question out of ignorance, I don't want to put you on the spot, but like with Apple and other stuff, I know like a lot, there's sort of in the global economy gradations of like, what is the final screw turned in America to completely manufactured in America, or some of the parts sourced from elsewhere. Like, is that a thing with the Berry Amendment, or?
Absolutely, that's a really great point to bring up, because that's the question. There are exceptions, like you can maybe source something from a foreign country, but if it's reprocessed in America, then it might meet the standard. But what does that mean? And is it one screw? Is it, how do you define that? And that's where the lawyers, work our magic, I guess, and they'll provide guidance on what would be the regulations.
Great. Thank you.
Yeah.
Yeah, so just, in anticipation of this topic, so I looked up, for example, this on the right is part of a profile from our WorldCheck product. So this is the risk product of someone who ran afoul of the Berry Amendment recently. So it was a contractor in Alabama who supplied baseball caps to the Army that he purported were U.S. made, that were in fact made in China. He's in jail now. So this is his profile in WorldCheck, which links him to a company called Lamar International. And here's the profile then for Lamar International in Icon, just a partial thing here. We can see that they have a Perm ID, for example. So, you know, on the one hand, there are very few cases that I was able to identify that were prosecuted.
And you own Westlaw. So, just saying, go on.
Yeah. So, so if you wanted to do, you know, like a predictive analytics around risk, you wouldn't have very many cases within that were actually prosecuted that you could use as your training set. I was talking with one of our friends here from the Defense Logistics Agency, and they were saying that not everything gets to the level of public prosecution that people can get on sort of lists of you know, disfavored suppliers, for example. So then that raises an interesting issue for us at TR, for example. So in WorldCheck, there's a lot of concerns about, so we maintain these lists of people who have committed crimes. You know, if something doesn't meet a certain criteria, then we can't include them in our list, because if we do, then we get sued. If we keep people on the list after they've, for example, been arrested but not convicted, then they can also sue us, because people use things like WorldCheck to determine whether someone should have be allowed to have a banking account as part of the anti-money laundering system. So there's a lot of interesting things to go there that about having data that you could do predictive analytics on, but whether you're legally able to gather that data or use that data for those purposes.
I have a question.
Yes.
How do you organize the strategy for keeping this database updated?
So currently we have, you know, again, a lot of people whose full-time job is maintaining this database. So we have 300 or 400 people worldwide in primarily in South Africa and in South America, who do this for a living. We did spend a lot of time this summer trying to, you know, think about ways that all that human effort could be augmented with data mining tools and so on.
Okay. And then do you have new people that also outreaching for branding you?
Yeah. So we also do have partnerships with NGOs. Like we work with a fantastic NGO called Liberty Asia that works on forced labor primarily in, you know, South Asia. And you know, labor trafficking is a much more significant problem than sex trafficking. And most of the world's labor trafficking takes place in Asia. But Liberty Asia works with NGOs who are on the ground dealing with these situations. And Liberty Asia actually provides tips into WorldCheck about you know, providing public information about companies that maybe you you want to think twice about dealing with. Yeah, sure. So then, you know, we've also been involved with the UN University that did a workshop last summer that provided input into the UN Security Council resolution on human trafficking, and talked about what kind of data gathering and so on should be encouraged to help mitigate the problem. So there's an opportunity for a virtuous circle where laws like the Modern Slavery Act encourage corporations to then be more aware of this stuff. They have to report this stuff, so they have to report what they're doing about keeping forced labor out of the supply chain. So that means they have to look into it. If they look into it, they need data that encourages people to provide the data. The more data, the more the problem can be mitigated, and so on. So legislation like this provides this virtuous circle to create more data, which leads to more enforcement. So we're happy to participate in things like this that lead to that virtuous circle. Right. So that's all I have about, you know. So to summarize, what I talked about was we've got this system of identifiers. that link to other systems of identifiers. We've got tagging tools that identify the presence of things that have the same denotation as those identifiers and tell you which ones. That allow you then to process data in bulk. And by doing that and looking across these data sets, you can aggregate information across these different organizations, for example, and then start doing things like risk profiling or other kinds of profiling about organizations.
Actually, I want to make a list of the tools that, and these are tools that we could use to hack on today, right?
Yeah. So a lot of them are free.
So what's the first one's called?
PermID.org.
Okay, Perm ID. Capital ID?
Doesn't matter.
I'm making it capital. .org. And everyone's seen that. So that's the ID one. And what was the next one?
So part of that is TRIT, T-R-I-T, Thomson Reuters Intelligent Tagging.
T-R-I-T.
And then those are the limit of the freeware.
Okay.
Then you've got
pretty good though.
Things
and
like
you can pull addresses off this, or if you start the name, or you have the address, maybe you do a lookup and find the name. And that's API, REST API.
Yeah.
We could do nothing but this for like 2 full semesters.
That's true.
Like this is awesome.
So then you've got databases called like WorldCheck for risk.
Okay, yeah, and then we're getting to human trafficking and
all kinds of any kind of financial crimes.
WorldCheck.
Yeah.
So you want to contain your risk, you want to avoid your risk, WorldCheck.
Yeah. Icon, EIKON, has all the financial info.
Okay.
What else? What else we got?
Block one, yeah.
Oh, right, of course. And we did that pretty well yesterday. Block one ID, I guess, right?
Right.
And it's capital O.
Yeah.
Okay. It's shocking that my writing is like this with this weird angle. .org.
Block1.tr.com.
.tr.com.
Yeah.
Lucky that I didn't draw the line down that far. So I go. Okay.
All right, and so Amit's going to show us how to do smart contracts.
Okay.
Now.
All right.
Can I?
And you know.
Any questions before we?
I actually have one.
Yes.
I'm sure it's related, like, you don't hang out, maybe on the but do you have any initiatives on pedophiles or protecting child abuse and pornography?
Child labor, human trafficking, yes. Not, no, not really.
Great. So, what do you need to show the smart card? Do you have to project from your thing? Do you want to do it right from the Hangout?
I can do it from the Hangout.
Yeah.
Okay. Outstanding. Actually, I don't know. I know who you are, but I think it would be nice if other people could get a squib on who you are and what you do.
Sure.
We know what you like already.
Yeah. So my name is Amit. I've been at TR for about 3 years. Actually, a lot of my focus at TR has been doing NLP type of work, so natural language processing, machine learning. Been recently getting a lot into deep learning, and so experimenting a lot with that. There was about a year ago, I got really interested in blockchain and started, reading a lot about it, specifically the Ethereum flavor of blockchain. And I started playing a little bit with Solidity, which is kind of the programming language that you use to write smart contracts. And I think, I don't know if you have any questions or you'd like to know something, feel free to ask. I'm going to give a disclaimer. I'm not a Solidity expert. And I don't know what the audience here, how technical you guys are, but
just a quick show of hands, like who's written a smart contract in Solidity? Anyone else? I guess I have, but the grad students and experts holding my hand full time. No, nothing? Really?
No.
Okay. So we have several people who I think could pick it up very quickly, and then some for whom probably would be completely fresh. including just, like a method and a function, like some non-programmers.
Yeah, yeah. So, I mean, if you've written a smart contract, this would be pretty boring, but, or maybe not boring, but it'll be pretty obvious to you. But, so let's see, screen share. Entire screen.
It's
I'm
fun.
looking at one
Wow.
second. Here you go. That's Brian.
Is it sharing the screen or?
Wait, this is you? This
Yeah,
is
that's me.
What is it? And
Yeah, I think so.
there you go. We got it. You're good.
So, so yeah, I'll start by saying that it's a TR. We've been getting into blockchain for I think a little more than 2 years now. We had a hackathon in London in 2016, and just to show you how crazy things have gotten with blockchain. The winner of the hackathon got 1,250, I guess this is pounds, and 25 Ethereum coins.
Wow.
And then the second place got 1,250 and 50 Ethereum. Now, obviously, and the idea here is that the 1K travel was worth more than 25 Ethereum coins. Sadly, that's not true anymore. This is like $50,000.
Yeah.
Um,
And growing.
So we had another hackathon in 2017. Give any Ethereum to the winners.
Are you serious?
Yeah, they gave 10,000 francs though. So
Yeah.
Boring, inert.
yeah. But yeah, so we, some of the winners, they looked at the intersection of blockchain and Internet of Things, the IoT world, or applying blockchain to fight fraud and supply chains, and we can. I don't know to what extent we can talk about those.
That means don't talk about it.
Yeah, but we might be able to, and I just don't know.
Please don't.
Okay. So yeah, so these are public things, and all of these hackathons were run using the Thomson Reuters. So we run our own blockchain. So of course there's Ethereum. But there's another one that we run, and I think you guys were playing around with it on the Norse board.
Exactly. Yeah.
Norseport. We love Norseport.
Yeah.
We're all Norseport guys here.
Yeah.
It was interesting. And, I mean, if it comes up and if we do a smart contract thing, everyone should learn about smart contracts. So I encourage everyone to pay attention to this, especially if you haven't done one. If we end up doing one, it would be great if you could obviously pair the team. But one thing is see if we could show us how to use an Explorer so we can go and check some of the transactions we did before, obviously, like either scan and so forth, where it pointed at the right, endpoint, shall we say.
Mm-hmm.
So just a little to-do list.
Okay.
Thanks.
Yeah. So I think I hope this is helpful. But what I'll do now is this smart contract, which do you want me to make this bigger?
Yes.
I think. Okay. Okay, so we'll go over this smart contract, which basically has two things. One, it has a setter, so it has a variable that you can set, and it has a variable and you can set the value of that variable, and you can get the value of that variable, and it has two other variables, which basically does some very simple comparison, basically meaning if this variable is greater than this one, return this. Otherwise, return the other one.
So the idea was that you have, very simple auction scenario. You've got some good, and you've got two bids on it. One person bids 10. The other person bids 20. Who wins the auction? The second person, because their bid is higher. So therefore, do something.
Right. Exactly. So. And the idea now is to take this piece of code, convert it into a contract that is deployed on the TR blockchain so that everyone working on this blockchain can interact with this contract. So basically, if you have, Ethereum coins, you can call the methods on this contract, which only cost the amount of gas or transaction fee and should be. Yeah, and you can get the values of these variables. So,
so one little point. So we've been talking about blockchains, and what I showed at the eDiscovery festival or wherever it was that we met at, is that we've been looking at it as a ledger where you can immutably enter a record of transactions. But there's another aspect of it as well, which is what we get at with these smart contracts, and that is that it's in addition to like like a ledger of like static information that is mined and processed. There's a distributed computation environment.
Yeah.
Like almost like an operating system in a sense, a virtual machine that you can run code on, and that runs the code on massively distributed clusters. It's basically anyone that just happens to wake up one day and decide to put a node on the network is now doing update of that computation. And so where does the computation run? Well, among other things, but primarily smart contracts.
Right.
And so there's a syntax in this language, which is called Solidity, that will run certain operators and other like functions and methods. And we're seeing one now, which is like a classic hello world kind of smart contract, which is like the graded escrow and the graded, like somebody did something on the blockchain.
Mm-hmm.
So we're not like getting data from some alien computing environment, just happening right on the same blockchain, sort of if then greater, lesser, the stuff that Brian was just going through. So that's what we're looking at. That's the context. Does that make sense?
Is there another programming language that will also create smart contracts?
Yes, there's another one called Corda, which runs on a different blockchain. So there's Ethereum. Corda runs on I can't remember if it's Ripple or I forget. Oh, it's the R3 consortium. Yeah.
Well, now it is a Hyperledger project,
Yeah.
I guess.
Yeah, exactly. And every one of these coins probably has their own flavor.
You can do a smart contract on the Bitcoin
Yeah.
blockchain.
Can you?
Yes.
I think it's called Corda, actually.
Okay.
Corda is now a Hyperledger project. Corda was the R3 blockchain that was, they don't call it a blockchain, they call it a distributed ledger. That's important to especially the legal counsel of the banks that put together. That's the aspect of it that they want to underscore.
Mm-hmm.
Anyway, so a little bit about smart contracts, so we have the context, and this is really, really good. I seldom get into this partly because I need to learn how to write them and how to work with them better. But this is, many people when they say blockchain, this is all they mean, smart contract.
Mm.
So please continue.
And I guess the thing about Solidity and why it's why people are why they like it is it's supposed to be Turing complete, or
yes.
So anyway, so the idea. Okay, so let's backtrack. So the idea is to take this piece of code, deploy it on the blockchain, so that all of us can interact with it. So we're gonna copy this code, and we're going to go to this helpful website, which is called remix.ethereum.org. And it's basically an online Solidity editor. And you can get to this website by Googling online Solidity editor. I'm sure this will be the first link.
Remix.ethereum.org.
Yeah. And so I'm gonna, you can just paste it in here like that. And yeah, so I had this code that I have written, and I put it in here, and then you can actually right away interact with this from this editor without, and this is just your local. It sort of emulates what it would do in the blockchain, but so it's only you interacting with the contract. So basically, if you go to run here, and I'm going to create an instance of this contract, basically deploy it locally. So I can do create, and you can see here at the console log, just a little hard to read. So let me zoom in. I wonder if I can make this. Okay, here we go. Okay, perfect. So this is kind of the log, And now you can see there's three methods here. One is called set, and you can put a value there. One is called get, and you can just it's a call method, and another one that's called get bigger bid. So if I put a value for set, and I can put 1 2 3 1 2 3, and I click it. Once I click it, watch what happens in the console. So it's gonna send a transaction. Everything in smart contracts is based on transaction. So I'm going to send a transaction to this contract that has been deployed, that has an address, and it's going to call this method called set and feed the parameter 1 2 3 1 2 3. So then when I click on get, this console should hopefully. So now this contract has stored data equals 1 2 3 1 2 3. If I call get, this contract returns 1 2 3 1 2 3. Great. And so that's the value that it returns. And if I call this other method called get bigger bid, which basically returns, you can imagine a scenario where we have two bids. One is 10, another one is 20. Bigger bid, which is bid 2. So it'll return 20. So this kind of emulates the contract locally on your own machine. And now the idea is, let's take this contract and deploy it on Thomson Reuters Norrisburg, so that all of us can interact with this contract. And so to do that, you need two things. You need the ABI of this contract, and actually I think that's the only thing you need.
So if the contract is a thing with an address, like my wallet has an address,
right?
What's the relationship between my wallet and a contract?
Everything has a contract. Everything has an address on the blockchain. A contract, there's no relationship between your address and the contract address.
Okay, so
a lot of contracts actually have a value, just like I have a variable. And when you deploy the contract, you set the value of the owner to your address.
I see.
You don't have to do that.
Okay.
That's interesting. May I ask a question about that? When a smart contract is entered onto the, how do you say
Norrisburg. It's just a network.
Onto the Thomson Reuters Ethereum, blockchain. Is there no? I would think that there'd be a way to know which what would I call it? I guess like transacting party that has an address on the blockchain entered it onto the blockchain, even if they don't have maybe an owner field. Is there not some way that it doesn't have to be kind of signed and entered? Or could it just somehow anonymously appear? And if so, how would you know how it got there?
Good question.
Okay, so let's make that a second thing for later. One is to explore, and number two is let's look at some smart contracts up there, interrogate the blocks, and just see what we can see.
Yeah, and I think the thing to make sure about smart contracts, and this is very, very, something that you have to make sure, when you interact with smart contracts, what you're going to get is an ABI, which is basically the definition of the contract in this way that works. But you can actually generate your ABI because there are things that take the code, the contract code, and generate the ABI for you. And what you want to make sure is that anytime you interact with a contract, you're interacting with code that you have either looked through or hopefully understand, because you don't want to interact with a contract that could potentially take things from you that you didn't want to.
Classic legal example that I feel like it'd be should be a fireable computational law instructor offense not to bring up right now. Would be the DAO hub.
Yeah.
So how many people, show of hands, who doesn't know what the DAO hub is? Haven't heard of that before. Okay, this is important. So DAO hub, really important. So just to really underscore this point. I don't know how many millions of dollars, was it tens of millions, hundreds of millions?
It was 100, about 130, and I think 33 total. Sorry,
not at all. So for this, there was Mr. Poppers tells us, our resident crypto genius in the community, Telegram style, said some 130 million. So a large amount of money was invested in a smart contract called the DAO Hub. And the idea was that people could put money into this smart contract, and then it had some code that allowed everyone to put money in, have a vote in projects that the money could be invested in, like interesting projects that operated on an extended, in that case, the Ethereum blockchain, Ethereum public blockchain, and the thinking being that could be, you know, a money-making fund. You could make even more Ethereum and also promote Ethereum to some extent, I think, by having an investment vehicle for projects there. And turns out there was a one of the features, or really frankly bugs, according to most people, of that contract language, was that it allowed for a participant to more or less empty out the fund by exploiting, many people would say, a unintended functionality of the code. And it raised a lot of major questions. So some of the almost doctrine, or practically feels like theology, for some folks that are all about, we need to switch the economy and the basis of transactions to a blockchain because it's immutable. It's, you know, cryptographically, you know, mathematically certain what will happen. So we don't need all these lawyers all around and all the uncertainty. Is that they felt like, hey, you could look at the contract, you could inspect it, you would know exactly what would happen under all conditions. And if that's where you want to put your money, go for it. And so it had expected results, according to those some people, or that you should have known better. Almost sort of a libertarian kind of feeling there. Other people felt like this was clearly a conversion or a theft, or, you know, it was unintended, and it was constituted kind of a fraud, to the point where it was so many people, so much money, it was such a disaster that they had to fork the entire blockchain. Everyone was just minding their own business with their addresses and their transactions. The idea of the immutable ledgers and all there. No, not so much. Like, they terminated the blockchain, rolled back the clock a little bit, undid that set of transactions, and then they kept going forward. So they fundamentally had to make like what would be considered a deletion or a rollback or a fork. So this is like what you call the canonical case of like a big smoking crater of a disaster, where you know, a little bit lawyering and security expertise into some of the protections you get in like post-medieval banking, you know, would have done a lot of good here. And so, you know, this theorized maximalist view of, like, you know, like a barren terrain of you know, free people and free markets, you know, doing, you know, gutting it out in a computational you know, battlefield, it may not be the terrain that's appropriate for all transactions or expectations. So in finding reasonable ways to inject some substitutions, some, you know, some rules of reason and role for attorneys is I think demonstrably timely and appropriate to be looking at. So that's DAO Hub, and that's why, like, that those last few words really bore a little bit of explanation. Like, you really want to read through the contract and have people that understand how to read the contract before, you know, messing with it. Having said that, these things are really interesting. They're really great, frankly, to have a contract that's on a shared network that everybody can look at, and something like that, especially a workaday, high velocity, high volume, very repeated, simple thing, like, you know, like I brought, you know, 10,000 mops and buckets, and I get paid this much, and shipping, receiving, somebody check the box, and these mechanical payments, as opposed to 60 days, 90 days, and a lot of paperwork, could be major reductions in drag and needless inefficiency, while still maintaining a very good, high integrity log of what happened in accountability. But for exotic derivatives and, like, you know, other types of financial instruments, you know, perhaps not so much. And finding that balance point in application is partly what we want to do, you know, in the last part of class, when we break into teams and use the technology. So, sorry, that was a little bit long-winded, but I wanted to make sure there was a teachable moment in what you said there. Okay, so back to you.
Sure. So now to essentially deploy this contract, what you want to do is I went don't know if you guys saw this, but so in this editor, there's run where we can interact with it just locally, and then there's compile. And if you go to details, you scroll down to the Web3 deploy here. I can just copy this, paste it, here, and call it something different. Call it. Actually, this is fine. So
Let's make it my awesome MIT contract.
okay, that's fine. Something awesome, and you can do this kind of thing to make people happy. Okay. All right. So okay, this should work. So now we can go here, which is I've connected. So
Where is here?
right. So let's take a step back again. And so if you go to block one, which is the Thomson Reuters blockchain kind of umbrella, and you look at the Norse board page for documentation, is actually very helpful instructions about how to send yourself Ethereum coins on this blockchain, and how you can kind of get up and started running a Geth node, which is a miner, but you don't really have to do that if you want to interact with other contracts and so forth. But running a Geth node is essentially running your own miner locally on your machine, so that it connects to the TR network, but also you can everything that's happening on the network through your machine. So I downloaded the zip file, and that had these files here. It has this folder, and basically you run Norseburg node just like the instructions say here. So unzip it and then run this. So then once you run that, in the beginning it takes about 30 minutes to download the blockchain and synchronize with it. Keep in mind, if this was the Ethereum blockchain, it would take probably a full day, if not more, because it's very big by now. And so once you do that, you'll end up at this console screen, and hopefully I can excellent this. Okay, so we have this console screen. Now I'm going to take this code and deploy it, and basically just paste it in the console. Hopefully, it doesn't really make sense like this format just because of what's happening here, but if I press enter, you can see you have a transaction hash, right? Every time you send a transaction to the blockchain, you get a hash, which you can then use Etherscan, what Daza was saying, to track the transaction to see how many confirmations it has. And basically wait. Here is because the TR blockchain has set the difficulty of mining these blocks as very easy, so that I'm right away, because we're using it for experimental purposes right now. It says the contract has been mined, and it has an address, and this is the transaction hash. So this address is the address of the contract. This is what you can use now to interact with this contract. And so now let's see how to interact with it. So
sorry, can I transfer from this wallet to someone else?
So what do you mean transfer from this wallet? So every wallet has
No, if I don't know from your blockchain, whatever contract I'm mining, do I need to keep it there?
No. So this contract is now on TR's blockchain, so that if you connect to TR's blockchain, you'll be able to interact with it. Okay. And all I need to really give you is the contract's ABI and this address. Now, again, don't ever trust an ABI. You always ask to see the code, but in this case, sorry.
And ABI stands for?
Something.
It means, ABI means.
Let's see.
Actually stands for, I do want to know what it stands for. I'm sorry to delay.
Yeah, no, that's fine. It means application binary interface.
Ah, cool.
Okay.
Application binary interface.
Yeah. Okay, so
I want one of those. Right, like right here.
so what do we call? So now we have a variable called my awesome MIT contract.
We call the variable.
I think we did. We
We're
call
feeling
it?
good. Or do we not set the variable?
I think it's this one. Okay.
Or set the method?
Yeah.
Ah,
So
there we go.
So we have the ABI
lightning fast.
and we have an address. So this is the contract ABI, and this is the contract address. And these are the functions that we have. We have a get function, we have a set function, and we have a get bigger bid function.
Okay. So like a cartoon, like a contract, you could imagine.
Yep.
Okay.
And now so remember there's a function called get bigger bid, which if I call get bigger bid, can everyone see that? Is that too small?
My eyes are terrible. I don't know if I'm the only one. Can you see that? You can? Okay. So I'm just owning my bad eyesight.
So we have get bigger bid. We can call that, and it's going to return the bigger value of the two bids, and hopefully it returns 20. So it returned 20. Now, to call functions on a contract, you don't need to actually use any gas or any fees, but because it's not actually a sending transaction. But
So we have to, just let me take one sentence there. What that means is, we haven't mentioned that one of the sustainability, almost like infrastructure as sustainability mechanisms of blockchains, really from like Satoshi's papers, are what we call Ethereum gas, and it's like let us just characterize it generally as small transaction fee, but it adds up. That is like assessed to transactions, and that goes to miners and goes to lavish parties. Okay, it goes to miners, and so you need a certain amount of gas to make your transaction go.
Yeah. If you want your transaction to go fast, confirmed fast blockchain, not Ethereum, gas, which means there have been transactions which have like $20 transaction fee just for it to get fast. But Ethereum is still okay.
Is the gas variable?
Yes, it depends on how difficult and how many transactions go on this block, and basically how fast you want it to be mined and all that kind of stuff. All right, so that's calling the method. Now we're going to set a variable on the contract. And so to do that, we actually need to call the set method. And then we're going to send a transaction to the contract. So it's going to be send transaction. And then we're going to give the value that we want to set the variable to. So I'm going to say 450, just random. And then you have to give it from where the money is going to be taken to use up for the gas or the transaction fee. So I'm going to say from my account, which is stored in 8 accounts, and there's only one account on this right now, so it's going to be the 0 one. If I press enter, it's going to send a transaction to the blockchain. So you have a transaction hash. Everything in blockchain has a hash. That transaction has to be mined. So you can see that it was mined. And now,
If I could ask a very simple
Yeah.
question. Can mining be automated?
Mining, what do you mean?
I mean, you have to have a person that's doing mining. It's not a person. By manual, so it's all automated.
Yeah. So basically, there's all these computers.
Like a farm, the mining farm.
Yeah.
That's the energy cost.
Right.
You know what
Because
I
you have to
mean?
have computers running
No, I
to
don't know.
mine the coin to
In depth.
drive the whole system.
Okay.
So people sweep up these computers, and they cool them down to try to make them faster. That's the whole thing.
So it's, all right, so it's basically
That's what
distributed
it's called,
energy
yes. Yeah.
that's running this farm.
Energy? Well, yeah, in a sense. So there's miners that are actually largely, the theory was that you distribute on like a SETI project almost. And, people will be doing it on home computers and like a little bit of your server farm or on downtime. what's ended up happening, probably because the incentives of getting a certain amount of the, transactions like Bitcoin or Ether is significant enough, and the value is going up high enough that there's a major concentration of mining happening. So China is, I believe, is not it's the biggest one of the stoppers on it. I'm like, I want the numbers. But basically, it's
They're starting to move along to Canada.
So that's also why when the government, Chinese government said they're going to start, controlling energy going to the miners. That's why Bitcoin dropped that day. And then they said, we're not going to. So again, this goes back to
real questions. And it needn't necessarily be this way. So I mean, a major part of the work in the Media Lab, Digital Currency Initiative, and other places is other incentive formula that we could use. Not necessarily like a proof of work with the cryptographic mining, which is very computationally intensive and that may not have the perfect set of incentives and disincentives based on the vulnerabilities that happen when you have high concentration, maybe in like an adversarial nation or people in collusion that may have a 51% attack and that kind of thing on the blockchain. Like, could you do it based on proof of stake, for example? So I don't know, like in the if it was like a NATO blockchain, if you're a member nation, you run a certain amount of nodes, maybe in proportion to your contribution or to your force structure or something like that. And so, like this is very, please hear this as something that's in play and that you can get your mitts on, you can partly fashion. Thanks.
So now that we have sent a transaction to the contract and we are interacting with it, we've set the value of that variable in the contract. So now if we call that, we call the get method on it, it should return the value that we set it to, which was 450. Oh, okay, great. You never know with live demos.
Live demos.
And now the interesting thing is, all I need to give you to interact with this contract is I need to give you this ABI, and I need to give you the address of the contract. So then you can say, on your machine, you can say, my new contract is going to be an F contract, which is located at, which has this ABI, and it's located at this address. And obviously, you're not going to have these variables. You're just going to paste this thing here and this thing here. You can't really see that, but yeah.
Is the smart contract, I may be using the incorrect word, exportable? And the reason that where I'm going in that is, how do you conduct e-discovery on a smart contract? How do you admit it into evidence in the court? What is the format for that?
You should stick around here longer.
Yes.
Because we love ourselves admissibility of blockchain evidence, mock trials, and moot courts. So please go on.
Yeah. So basically, all you need to do is that, and now you have this variable, and if I call get on it, it's going to get 450, and it should do that on your machine as well, because that contract is now on the blockchain and is a public contract that people can interact with.
But then 450, we're just getting the values, or do we get the relationship? What does 450 mean?
Oh, well, in this case, it's just an example, but you can get, for example, imagine a contract for voting, where you have two candidates, and each candidate has a certain number, and you can vote for a candidate, and then you also want to see who has how many votes, right? And so you can make a method that returns two values, one for candidate A, one for candidate B, and that will correspond to the number of votes each one has gotten.
So if I wanted to set the value now as not you, I could, it would cost me some money to set the value. And then when I did get, it would return the value that I set. And anyone else who did get would see the same value.
Correct, for free. Yeah.
Can I take a quick shot at answering the discovery question?
Sure, go for it.
Okay, and then do you have more to show?
No.
I'll answer the question, then we'll go to Brian. Sorry. So there's a question about what if there was e-discovery on the contract? So let's only go on the contract, let's say Dow Hubbard Ripe and did some litigation, for example. people wanted to introduce the DAO Hub smart contract into evidence. Like this would be very foreseeable in litigation over the DAO Hub contract. In fact, I can't imagine how any set cause of action we wouldn't be entering that in evidence at some point. It'd be relevant to certainly contract breach and maybe to other misrepresentations and on and on. And so that's a good question, because I don't believe, to my knowledge, no one's ever had to do that before. And so in this very room, a few months ago, Christian Smith and I and others did the beginnings with Massachusetts legal hackers trial to enter into evidence under the Massachusetts Rules of Civil Procedure, which I vaguely recall. And we had some current litigators in the room with us. Basically, the witness laying of the foundation. And the first thing we postulated was a contract breach, and we further postulated that we were looking for the business records exception, because you have to apply the law of facts. And then we had a person talk about how like my job at the company is where's the effect of like doing the blockchain-based transactions, and I keep my records in this way, and this is how the technology works, which was a lot harder to explain as though you're talking to a judge or a jury than I ever would have imagined. So we learned that we need easier, simpler ways to do that, and easier diagrams and explanatory, things that you talk about in court, which was a skill we didn't happen to have, so we identified that. And then at the end of the day, what we felt, just by way of research and development question here, was going to be our best bet would be to do a printout on paper, I'm embarrassed to say, as like exhibit 1, exhibit 2. And where I wanted to get, and where I feel like we ought to get, is just completely electronic. Maybe a printout for some kind of archival purpose, but the authoritative thing should be something we display on a screen in the court, and the judge ought to have an explorer and be able to do the same things. The counterparty should be able to hack at it, and we should be able to show the code. We should be able to enter into evidence the then current version of Solidity, or the programming language. And I would say, honestly, the full blockchain as it existed, at least as of the time of that transaction, or as of the relevant span of time, which is, as I mentioned earlier, is also a little bit of a lift. Maybe it isn't so much with yours, but for the Bitcoin and Ethereum blockchain, putting it like in a CSV format or something anyone could ever understand is a whole thing. So these would be some of the rudiments we imagine would be necessary for laying a foundation to enter evidence under rules of civil procedure. But I used as a guide, thanks to like some Westlaw searches and stuff like that, just how do people enter other exotic electronic evidence into electronic artifacts into evidence, and just how do they lay that foundation? What are the objections? Were very, very instructive when I looked at how do people get tripped up doing it? How do we not get tripped up? But as far as I could tell, the major issues aren't like there's no rule against it. It's a record, and there's a transaction. There's been a dispute. Common law courts are fantastic at, and our administration of justice can adapt to these new things. The real thing would be for the litigators, so the JAG or litigation. Like, what do you say when everyone's looking at you and you have to make this understandable? Like, come on, this is going to take work. I think this is going to be like years of CLE and mock trials to start to hone this, and we'll have to really keep our ears open when you hear the turn of phrase and when you see the good diagram and start to accumulate this stuff into practice pointers and manuals, and just keep getting better at it. So, does that make sense?
Yeah, great. Does I have a question?
Okay. Since smart contracts are written in code, they're in language, is there already established language for certain functions? Like, for example, that the bigger bit is that something that is already previously written so that you can just kind of use?
So you're talking about, so I think in programming, can sometimes be called like polymorphism or inheritance, where basically you write a contract, but instead of rewriting the wheel, you just say, for this part of it, let's just take it from another contract. I think you can do that with Solidity, and he knows better, so you can do that. Yeah.
So you can do what like we were talking last night of nesting everything. You can
Yeah.
Because it seems to me smart contracts really an order of operation of
Yeah.
that's functions, right?
Right.
Yeah. So
And that's the thing, it has to be deterministic, right? Because the blockchain is deterministic. So, yeah.
Any other questions, comments?
So I had a question. So someone risked me off on Ethereum, and
There is precedent.
yeah. So I know the address of the wallet where I think my money ended up, or I know the contract that took money from my account and so on. Can I sue, the owner of such and such address?
You don't know the owner of the address.
No, I know. Right. So can I?
I think he's deliberately asking this question
Oh.
in this way because he's a funny guy. So is that a setup for me to talk about connecting those dots forensically?
Yes.
Okay. So I'll just say a couple of things about that very quickly. So, that's a good question, Brian. Turns out that unlike, say, like a NASDAQ or like a New York Stock Exchange transaction with registered brokers and dealers, that the address at the postal address of the officer to whom legal service or process would be presented isn't one of those fields that we saw in the blocks in the blockchain. So that's a pickle when you actually want to get a sheriff over somewhere to get someone by the scruff of the neck and maybe impound their car, to compensate for the ripped off value of the transaction. And so, one thing to say about this is that blockchain is not an anonymization machine. And so there's a lot of signals traffic that you can get with IP addresses at the endpoints, even with people using Tor. So if you really want to put some shoe leather into it and investigate it, there's ways to put it back together. And the other thing to say about it is that we had a great MIT legal forum thing here where legal forum what do we call it? Show where we talked a lot about what we call dual integration. And Monex calls it that, and sometimes we'll call it, I have different words for it, but basically the idea is if you want to be known by your counterparties, you can include in op return or in the memo field, we could use the Perm ID, or you could put some other identifier there, and you could also link to the legal contract if it's on a public procurement site, you have a URL. In the URL, you can include the address on the Ethereum blockchain of a smart contract that's connected, and even the addresses of the counterparties. So you can basically do cross-reference if you want to maintain provenance of legal entity identity on the blockchain transaction and blockchain addresses and transactions on the legal contract. And where I do that when I model it, I haven't done a proper deal this way, but I'm just modeling it. I've done it like a combination of this is between Acme Corporation and Beta Corporation, a company of New York with blockchain address, yada yada yada, and this contract correlates to the smart contracts at this address and that address. I just write it out. I'm not interested in making it hard or confusing. So but I think it's a live question. It's a live question.
He's got a live question.
Isn't that the idea also of the identity, of having identity on what we're doing, in this discussion class? The purpose of identity is so that you can do all those kinds of things. Is to create that one universal identity that you have to use for everything as a solution. So that
self-sovereign identity.
Yeah, there's an identity aspect here. There's questions like which identities are using, what identity functions and services are necessary. And when do we want to allow whistleblowers or others to actually have some pseudonymity, or how do we accommodate these use cases? So yes, and yes. Sadly, this show is coming to a close soon, so we're going to change the format a little bit at the end from breaking into groups where we may have timed out because I didn't expect to get so much great more education. So I didn't want to short circuit the education, and which we have actually now available under Creative Commons YouTube. So all of you going back to your offices and your other countries and things can actually see this, share it with your friends. Take part. You're welcome to post more questions here. We'll be here. We'll keep collaborating with the Thomson Reuters labs and others, and we can keep the channel open. But what we'd like to do instead toward the end is more of like a discussion, so people can talk about the use cases as a group and wrap it up in that way. And to start with, superstar legal hacker and the first like fully authorized and deputized teacher's assistant of computational law course, Brian Wilson, has actually done a proper hack from the use case. And I just asked it before you have to rush off to get your train, if you could walk us through it. So Brian, take it away.
So with this whole course, one of the things that we wanted to focus on was obviously the Berry Amendment and the Buy American Act, but we wanted to kind of generalize that so that you could identify the provenance of a good, track it throughout the entire life cycle of that good, and determine where it came from. And on, what was that, Saturday?
Yes.
On Sunday.
Oh, yeah.
Late Sunday night, we were trying to figure out ways that you could do that. That would be easily hackable and wouldn't take very much effort. And we stumbled upon CryptoKitties, and we're talking about them and noticed how they all have unique features. So on this page, you can see some of the features include fancy and chipcat, but you can also track the provenance of these to their parents, to all up and down this chain of things that happen to them. And we were like, well, that's pretty cool. They all have these different, they all have different features that are unique to them that represent specific traits. And so our next thought was, well, what if we could take a hash value and then somehow generate our own images that could be placed on a good or something and used to track the origins of that good at each point during a supply chain.
Yeah, could be placed on a label on a physical good, could be embedded into a digital good.
And we stumbled upon Identicon.net, which creates really cool unique images based on exactly what you're typing. And if you even do something so much as change the capitalization or delete a space, it will completely change the image. And so what we wanted to do to kind of prove this out a little bit was to take hexadecimal hash values from the Ethereum blockchain that are used as real transactions, put them in a table, then figure out a way to insert the images into a different table. And this is what we kind of put together so that you could see each time maybe a good goes through another supplier or distributor, they could insert one of these images on it. And you can make sure based on all of the transactional information that is stored in these hash values and represented by these images, you could have a greater degree of certainty with where the provenance was coming from, and use that as a way to identify, for example, that your goods were made in America, as you need to for the Buy American Act and the Berry Amendment. So.
Ta-da! Nice hack. Good one. All right. This is the way we hack the law. All right. So, any questions or comments on all that? Yeah. Or
is there some more database that maybe Thomson Reuters from this week that we can do the backwards? We can get identical and identify, break it down.
I'm sure there would probably be a way to reverse engineer it, but they have so Identicon has all of their information on GitHub here. So I'm sure if you toyed around with it long enough, you could figure out how to reverse engineer it.
For what purpose?
So being able to like
do what?
Like go backwards. So from the image.
Go back to
into what the hash was?
Yeah.
I don't know. For whatever it's worth, it looks like it has the properties of a one-way hash to me.
Okay.
It doesn't seem to retain enough information to be able to do that.
Because I'm thinking like supply chain, let's say about
So like
share
real-time feedback.
suppliers, and then eventually there's an issue happening. I'm thinking then a system that tries to the compliance of this. If you have like every time this same supplier is gonna be a different chain, he's gonna be having a different feature. I don't know, I'm just thinking could we use it to finally to go backwards?
Backwards from what to what?
From the image to
image
the hash. To the
Image to the
and then
hash.
from the hash to the
To the transaction?
yeah.
Yeah, so a major property of one-way hash functions is that they're one way in the sense that there's just insufficient information from like a 26, digit string ever to derive that it was the Library of Congress or the entire Hubble, telemetry or, like a 5-line poem. Just there's no way to know that. Like you have to go through every combination of characters and, and like ASCII or other sequences until you get the same hash result. And like that's obviously very difficult, and that's also partly why they're hard to, why they're good at being checksums, and why it is that you know to really like a very, very high degree of certainty that a hash that results from a given sequence of information is definitely that information. So it's certainly tied in that one direction, but but we want short hashes, and in this case, what we actually want is a trade-off in terms of it not being two-way verifiable. But what's great about this is like the CryptoKitty, which is how we started this, is that a human being can look at this CryptoKitty or can look at that square, and then we're good at the processes in our head to distinguish the difference. So you can have an auditor or a person in shipping and receiving kind of look at something on a box and look at what they were expecting and say, is that the same? QR barcode? Not really. Now we're into hard manual processes, or like, imaginary, never quite work, robotics, shipping and receiving things, where we're still a ways off here. But now we can have everybody understand it quickly. Let's let some more people talk a little bit. Any more questions or comments?
So if you created a digital way to store these as receipts, kind of, you could just make sure that the two matched up. So the Identicon that you would start out with is the same at the beginning and end.
Yep.
So that would be a way to kind of like get into more of the selective privacy.
Selective disclosure.
Selective disclosure.
Yeah, and continuity.
Yeah.
So it certainly has continuity, but so it's adjacent to reverse. Mila, did you have?
No, I like what you just said, in a way that you can keep a record that is auditable, but you don't have to disclose any more information than you need to make sure that someone could be accountable for it. It's pretty brilliant, actually.
Hopefully.
Yeah.
When it comes to
Okay.
using this for like a supply chain that it's attached to a good, how do you track like what the transaction has gone through to make sure that like a good actually delivered to the person? Because we were talking about like with Bitcoin right now.
Yeah. So you could add at each thing that the good travels through, you could add another row, and so when the good starts out, you have like just one, but after it goes through all these people, it has like 5 or 6. Kind of in the same way with the cats, where you can see parents and children, but you can go up and down that chain and see, okay, it started out here, then it went to here, then it went to here, and based on the like totality of the images, you can see that it has gone through each of the right places.
But you need to trust that, like, if you had a contract where, okay, when I sell you like an apple and you receive the apple, like, do I trust that? Do you trust me first, or do I trust you first? Like, I guess that's the question. And like, how would that be actually executed?
I think that in the diamond industry, when they started, they stamped some kind of a hash or a picture of the actual diamond. And so it can be checked all the time so that it's the correct hash of the image that's being, and I think it's a 3D thing with like some complex number of parameters that's stored and that's hashed and that kind of, so the end result has to be exactly the same as the first. So if it travels around, it doesn't really matter. You take the same machine and take a picture, and you're supposed to have the same hash.
But so, like in some of these cases, there was a selective disclosure on the item, right? There was a tag that said "Made in China," but then that tag was switched for a tag that said made in the US, right? So doesn't there need to be some requirement that this couldn't be, associating this identicon with this element, that somehow has to be integrated in some way that couldn't be switched out, right?
Precisely. So, I mean, I know that you need to head out, unfortunately, but before you do, yeah, I have to use the other one. Before you do, we should probably get up to the point we love to get to in this course. So, one of the first ones of these we taught with when I was trying to learn blockchain was called napkins to launch. Because you always hear about like the myth of you scribbled something on the back of a napkin and Silicon Valley, and now it's a $2 billion, juggernaut of technology. So we were encouraging student projects like that. We actually got quite a few. So on the napkin last night, you scribbled.
Oh yeah, we have that on the wall.
Right here. Okay, perfect. So let me see if I can talk through it. Or who else was on the team? Well, okay, so basically, I'm just not going to be a great way to say it, but part of what it was the picture really good. Did we get a photo with the napkin?
We didn't.
Okay, so I'll have to redo it. So let's say you started T1 with you.
Yeah. So
T1's like the origin point, like ammo paste or. It's like you care about where the materials were sourced, it's like if you dug something out of a mountain, you refined something, you smelted something, you cased something. But here we go. Yeah, this is it. Yeah, this was the napkin.
It's reversed on the screen. I think it's reflected on the camera, but it's okay probably.
Reflected.
Power saving mode.
No. I think it's backwards, right?
Okay.
Right. Just keep it guessing.
Yeah.
There we go. Although I think actually it comes out on YouTube correctly.
Okay.
Through some trick of magic media gnomes, and maybe even a unicorn if we're lucky. Oh, thank you, Eli. Okay, what you got? So to take it from where do you want to start, Brian? Like you want to, I think in the movie War Dogs we start with we acquired a bunch of ammo.
yeah, so you get the bullets. The bullets come with this logo on them, and you can see based on this logo that you know what it is. But when it goes to the next person, you combine another logo with it, and so it keeps creating a unique logo. And it's represented here by what looks like a letter I, capitalized. And then you can keep doing that at each different point throughout a supply chain and make sure that this matches up with this later on if you want to audit and ensure that the origin of the goods is what they said it was. Because you don't know if somebody decides to change their mind or not.
Yeah. So additive, basically, and part of what's good about this, and it doesn't give you quite what Aura was asking about the, can you get to the whole payload from it? What it does give you, if provenance is your question, as it would be with something, of the type of bimeric and variant, with so many things, diamonds and so much, being able to just look at the label, let's just say the label says it has like the legal name of it, you need to think through what are the data elements that we care about. But I'll bet if I actually read the Perry Amendment or the other acts and I looked at the diamond things, like there's probably an industry standard, some other stuff with the key data people want, we probably have name, Perm ID stuff, and like how many poundage, and what was the make and model of stuff, and what was patents, that kind of stuff, transaction code. Figure that out, put it on hash it, generate the image. And now we've gone to a new place, and now guess what? We've got a new label actually too. There's some new stuff happening. It's been shipped and received. We have FOB. We take it right through the supply chain, and so you should be able to look on the box, visually inspect, and then you could reverse engineer. If I add this image and that image, do I get this image at any point? And if we get variants, you can figure out this is exactly where the problem is. It's like when it went through this port on this island.
But then someone has to have
The full
centralized
picture.
the full chain.
I'm saying you can add the stamps directly on.
Because I'm thinking like for kosher food, we're talking about.
Yeah.
Like kosher food, we have a whole supply. Let's say like 5 hashes ahead, there's a problem. And if they want to fix the problem, how do they localize it specifically if nobody has their own organization on top?
It's a transparent chain, so everybody can see it from. So you can see the entire chain.
Yeah, one of the postulates that we're making here with this property, I would just say, like, and it's like, this is novel, I guess I'd say, but like, and actually, Brian, while you're packing up, just listen to what I'm saying, but I think in practice, to reduce this technical innovation to practice in a way that is commercially viable, and that answers the questions that would come up partly from law. So if we have a dispute over origin at some point, what would you enter into evidence? What would you care about? And let me just play out that scenario. I think what I would do if I was like the person that had to do the application of identicons or cryptocurrencies or whatever to a supply chain, I would, after painful meetings, have every one of the supply chain agree. We will literally have a slip that has over much space for each square that we would ever want to add, and we would keep adding the squares to the slip in the order and the sequence which we would fight about, if it's vertical or horizontal and everything like that, as we go through the chain. And that in the extraordinary circumstance that we ran out, we would agree after fighting more, we will add a second main thing onto the right of the label, not the lower part. Oh my God, that's dangerous enough. We'd have to fight about this kind of stuff. And we would come up with a practice, but then you have to have, you would want to be able to visually scan every addition to this and have that be part of the display payload. So we'd be talking about basically like a D3 implementation or something with something where we have a standard way to have a card in JavaScript and that would show on the DOM. I would like would be what I would do if it was digital, and otherwise I would just be right packing label land to the RFID people and the QR barcode people and standards for all that stuff to add the stuff on. So I think that would be part of the idea is that it's got to be additive. Because if you just take it a sequence in time, you lose the provenance. Make sense?
Yes.
More questions? Well, first of all, I just want to, I think that, come here. Do you have your coin?
I do, it's in my bag.
Okay. Thank you for being a great first TA in the first class. Let's hear it for Brian. Here, and you genuinely did. So next year you ought to be teaching this class, I think. Just saying. So come back.
Yeah.
Okay, thanks. You come back and say promise.
Thank you.
Thanks. Legal hacker right there. Proper legal hacker. Great. Okay.
A quick one?
Or you want one?
No, I was gonna ask a question afterwards, like reading upon my desk.
Well, yeah, so let's have a quick conversation about where we're at. So it's now 4:10. 4:10. Oh no, I'm sorry. Doesn't that mean something? It's 10 more minutes. So there's a 4:10 is like a zip code or something. Not that. I have no vices right now, which is probably my biggest problem. It's like it's not healthy to have no vices. A nice little play. So, quick time check. I think we're scheduled to end at 4 o'clock.
Really?
Are we not?
I'm not asking.
Yeah. We're scheduled to end at 4 o'clock, so we could pack our tents and go home now.
No.
Anyone that needs to or wants to go is free to go. I should say that for sure. And then, and I'd like to suggest, my schedule permits, and we have the room, so we could also stay another hour maybe and wrap up at 5, and give time for what I would suggest is not group by group presentations or work. I don't think we have quite the time scale for that. And also, it's going to be a little late in the day, but I think an open discussion that maybe could be grounded in some of the use cases and look at to apply things might be. And might be called for to just kind of and also to synthesize what we talked about and learned over the last couple of 3 days. What do people think? What are folks up for?
I know.
Tiana's down.
2.
That's 2. Tiana?
3.
Three? Who's third?
Several minutes.
Just saying,
Okay. So show of hands, who's up, who's able, who needs to go? Let's start with that. It's okay if you have to go.
I think we're good till 5.
Till 5 p.m. And the coming down. Okay. So
That's good. Just call it.
you want to take a 5-minute break? So 5-minute bio break, and then and whatever. So anyone need water or coffee?
Yes,
Yes,
water.
Water,
please.
coffee. Okay, everyone needing water or coffee, follow me. You have vessels. All of you online. Drink, hydration. It'll take care of itself.
Thanks so much for doing this.
So we're all drinking. We're having fun. See you at 5.
Sorry, it was a great conversation. I was just asking this because somebody was like saying, like if there is a
That was
problem,
a trick of
any
the
type
eye.
of problem,
Trick of
someone
the
has to
eye.
have the whole lead, right? Otherwise, how do you know? Just like the head, but they have no idea who had the head. Someone has to have the controller. So I was thinking, let's say the caller has been having like 300 suppliers, and maybe for one type of supply chain, the same supplier didn't have a problem, with another 2 they had a problem. So how do we know? Like, before like holding like one-stop shop that I know this company is gonna give me the whole overview. How do I know this company has been keeping track of the different leads of supply chain the same company has been being tracked?
Yeah, I don't know.
So I don't know, like if for Perm ID, every company has only one hash, but then if we get to the point that every type of project to just change a little bit and then become another hash, it's gonna be hard.
Yeah, so there's actually other blockchains that are really good for having what's called side chains, actually side chain history. And so maybe you have a parent company consists of the main chain, and then each one has a side chain. That's why there's all these other coins that are opinion.
Because like I'm thinking about, I keep kosher, and the whole kashrut world is like crazy. So even though we know such brands are kosher, we need to every different box, we need to check again the list if they continue to be kosher. So like there are some people in the Jewish community right now discussing, they have already Bitcoin, Bitcoin is like a Jewish coin. Yeah, it's real, like it sounds like joke, but it's real.
I'm Israel.
Yeah, so totally invested. And now people are discussing the Litecoin to be like a cashless exchange. And that's one of the discussions, like, okay, how do we know that the off-chain organization is being really being updated on the chain? Because there's always no trust, and then like 2 companies that bring the trust, the rabbis, I don't know how many years you developed their own system.
You can make it your own blockchain with your own ICO and get hundreds of millions of dollars for it.
But if you are intending to keep kosher and someone, deceives you about something that you in good faith or it's no fault of yours, right?
So once we know, we should have the responsibility of not.
We've got a live question. Sue's ready.
Okay, sorry.
We're talking about kosher law.
That could be a good project that you want to bring that up. Maybe not to eclipse everything else, but I think it's a good application. Actually, do you?
So let's
Yeah, so is it interesting?
Kosher?
Yeah.
Yeah. I don't keep kosher. I'm Israeli. Yeah.
What an interesting use case, I think.
Yeah.
Okay. Yeah. So let's keep it as a live use case. I like that it's commercial. It's religious. It's it's retail. It's got a lot going. It's certifications.
Supply chain.
Yeah. It's a good one. It's a real good one. I want to, but so I think so the question that just came up, which is mostly for you, but I'd like you to hear it too. Please listen. Is the clever innovation that Mila was just asking about? Which is, can I keep trying to so basically, if you imagine, it's like point 1, I don't know, manufacturing, factory. Point 2 is like shipping, shipping, to like the warehouse. Point 3 from the warehouse to fulfillment center and start at point 4. So one of the causes there's a record of like I'm a dog I received and I signed the thing right down to like the consumer doorstep. I signed the package or UPS person, like you said, delivery. Just so that we can interrogate this data source. Could these things actually, some of these be trigger events onto a smart contract to change state or do some other things? Talk us through best practices right here on the Thomson Reuters.
Yeah. So there's smart contracts that listen to transactions that are happening on the blockchain. So whenever a transaction happens, triggers a method of the smart contract.
So I was making it a little bit more complex, which is why I wanted to talk it through. So what we're imagining here is not that it's a supply chain that occurs solely on the blockchain, but that it's happening in literally, like, just to say three, like what would be like there's enterprise like shipping and receiving that they're selling in SAP, and then here it's a UPS API.
Exactly an Oracle.
So how do we set up the
currently, how it works is triggered by financial instrument
Right.
stuff. But you could have an oracle that says, if this sequence of words appears in a news article, trigger this.
So let's say we did a supply chain thing, we wanted to get the way to do it, we couldn't directly go to UPS API because it's not supported in your chain, but we can pick it up in a news feed. So if we basically did a repeater in a news feed that we had control over and that you were ingesting, we could fake it maybe. So you know what I mean? Like MIT has a news office. Like, I could probably talk them into doing something if you're reading their, like, I don't know, like, what do you mean?
You need a service, so there's two things, right? You need a service that monitors changes in the world.
Would be a minor.
You might say you have a website that constantly goes after events from UPS, and anytime someone signs a packet, and you have access to that, anytime someone signs a package, your service gets that and then fires off an event. The service needs to be fired right now. Yeah, and the service needs to be fired out.
Could do that in the Thomson Reuters. You could integrate to UPS specifically. Well, the other one's GitHub, right? Like GitHub is a company.
There's another service called Worklights. Yeah, which is you can write your own oracles. It costs a little bit of money. It's not very much.
It's like a little bit like $100 or $1,000.
$10 to $100.
I think we have a jolly good hack on the Thomson Reuters podcast. I'm gonna have to check with the money man. Yeah.
To transact with those commercial entities.
Hey Brian, I got an idea. Remember how we were talking about like a small sponsorship from Thomson Reuters for doing these kinds of hacks?
Yeah.
What you actually want to say before the end of this is that like you're not a direct sponsor of the Media Lab, they're not paying you. Like you're here as far as I know because you want to be here, and it's the middle of a work day that you guys are here. And I think that's, I'm not sure how the everyone's listening to you, but frequently there's some angle that I maybe made the mistake of saying there's no love hacking with you. It sounds like an endorsement or advertisement, which could actually backfire against you. I feel like maybe you might want to say at some point, like, I might want to say like everybody, but like actually you're here on merit. It's not invited. It's not part of any business relationship whatsoever. It's taking them out of your day, and it just perhaps people will be able to hear what you're saying with the weight that I think it deserves, which is extraordinary. I think your contribution is really what I consider MIT great contributions. Thank you. I'll state that. But having said that, now that we're all feeling good,
Can we have
he told me that there's like a little bit of money needed for Oracleize, not a lot, but like, it would be more than enough within like the small amounts of like kind of pizza and other sort of amounts of money we're talking about over a year. I think if we could get that going, I would like to kind of continue working with everybody. Good crew people want to keep learning. If we could get Oracleize and then try it on the Thomson Reuters chain. If we could have enough lead time with people that have the Lord's back to look at like incorporating Oracle and doing with the Media Lab and maybe test kind of way. Maybe they feel safe trying some stuff. I would be happy trying stuff with your blockchain.
Or we could get people to set up an Oracle on our end too. You don't need to use Oracle LEyes. We set up.
Yeah.
And you guys can write the code for the Oracle, and we can just implement it.
I can tell you two that we like, which we could use. Like I said, it's just like if they're in blockchain. So one of them is number one is GitHub. Because you can cause GitHub to represent anything. When something happens, usually issues, like when something happens, when it changes things, it's got a robust API. It's like everyone knows if you like it. In fact, you can tie it to people's accounts and like. The second one in my book would be UPS, you know, so, or the other one, or FedEx, like, or maybe both is what we have to do. Just because that's real and they understand it. It's a distinct change, shows a lot, it stands for a lot of things. Those would be my top hacks. Then we can actually just do it, you know. You go back, you'll be in New York. We have a lot of people have actually roll it up. We have a big legal hackathon happening. We're going to have March 16th, 17th, and 18th. It's the computational law and blockchain, computational law and blockchain festival. That's what we're calling it. This is going to be one of the next things. But we could put it. If you had enough pizza, we could have people stay here.
March 16th, 17th, 18th?
Yep, so for weekend. I think there's right now in Tel Aviv. It's already on mine.
Is it?
Work on vacation?
Oh, but for the hackathon, you don't have to. I'm just thinking of having an artificial deadline by which you can work already and a little bit documented. To really make the most of it. We have a lot of people using it, and I would love that. Computational law and blockchain festival, like it's perfect for this hack.
Let's do it.
Okay, all right, that's awesome. You're so easy to work with.
Like, you never ask me something and I say no.
It's never happened. Can't think of time. So maybe if I could ask me, you can really get that. Yes. I'm like, that's great. Okay.
No.
So the answer is yes. Now do it your way.
That's what I'm.
MIT.
Python or R. Yeah, R as well.
Yeah.
Before you even bring I mean, actually, Python's running in pandas anyways.
Right. Yeah, Python. I really like Python. I've been using Python for years.
Yeah. All right. Cool. Yeah. I just learned to code. Cool.
Yeah. It's just, it's just like
doing it 4 hours.
It's a slow start in the beginning, but then, once you get the hang of it, you start to make more sense.
Yeah.
On Thursday.
When like
That would be great.
I think you know when they're trying to build a team. People actually know what they're doing.
Yeah, I think there's value in understanding.
Yeah. Thanks for yeah, sure.
Definitely. What's people's background there?
I'm like a crazy.
You're what?
At MIT. No, at the University
What's the company called?
Slams.
We put ourselves down to 85% accuracy, make cap control over what things were about, and then we use some
Wow. That's amazing.
Yeah, so we're still kind of keeping that. Things on the spreadsheet.
How big are you?
We just turned to receive right so now we're like ready to go and show further. That's
That's cool. I mean, you have the credentials. And also really excited about a lot of what you guys are doing is trying to create so two things, natural language processing to help read context, like create like on the other side, to actually those are the two parts.
Cool. You guys have a big challenge ahead of you.
Yeah, it sounds great. So I think allocate these to data set yeah, so they don't have to go through all the right. It's like, I know how to sell. Set up to reach out.
Yeah, I started studying.
I wasn't literally planning on coming.
No, that's good. I can probably on anything.
Yeah, you can find me on LinkedIn. Or I'll find you, I guess.
Yeah, that interactive thing is just the access, you know. Your work.
True. And then this name here, can we try?
Yeah. If you go to the blog,
So, assuming we're becoming really like pushing
I think you have to
Alright, we believe it. We're gonna take a week of tests. We can use like a zero time. And then we have like some who's gonna stay in the
oh yeah, my name is Michael.
it's like when we have to
Sorry, you
so we want to have
I mean, I've been pretty okay, yeah, I've been in the US for 9 minutes.
Yeah, that did the same. I was going to learn this work class for this me, yeah, no, I know that, but yeah.
Sneak out.
Nice meeting you, Ahmed. Can I have your email or something?
So do you have my full name?
Amit one.
I don't have a card on it.
That's his email?
My email is meet.shavina@tr.com.
Thank you so much.
Because I finally found someone that really knows what he's talking about.
Well, or I can fake my way to know what I'm talking about.
Yeah, okay.
So it's meets dot, yeah, dot should be. Yeah, S-H-A-V-A-T. S-H-A-V-A-T. Yeah. At TR.com. Okay. All right. Nice to meet you. Yeah, no problem. Yeah.
All right. Yeah. Parked over there. So probably will be out of five. So enjoy your Thank you. It's really funny because I think you 15 minutes before we came up, that's great. That's really great. Oh my God.
Okay.
What's OJ? His last album.
Yeah, that's what I was at the whole point. You just because as you're so much mispresented, you're basically writing.
God, that's delicious. So refreshing. We're gonna crack that open right soon. All right, cool, man. Cool, man. It's coffee. Is this neat? You don't want this. If this is yours.
Oh yeah, that's mine.
I can't help myself coffee.
I got this whole tracking on the supply chain idea, but David and I were talking, he had purchased something from someone one time, right? Watching, you can see like where the problem lies. I think it's better. How the vendors are in this scenario, how could you prevent that? I guess like because someone could, scam someone and there'd be no way of like tying it back to that particular vendor if there's someone that you didn't constantly work with them. Is there technology to address that?
To basically tie the
The actual, yeah.
With
the blockchain. Yeah.
And then one, cross-referencing them.
Okay.
That's the most correct one.
Yeah.
She's come up with more.
Okay.
We should, if you want to do a thing, like say it as a, say it out loud.
Yeah.
That's a good one. Identities, I think, is great. 2018 is going to be identity and blockchain. You'll see.
So I have a.
Do you want to say it in the context of restarting?
Sure. Oh yeah. I'm restarting now. Yeah.
Okay. You can see the control then, or if it's like sort of first bathroom. Okay. So who's? All right. So I recognize ye all as the diehards. That's awesome. That's perfect. The ones who like the survivors. Many people have fled. All right then. Let's reconvene.
Hi.
Thanks, Lisa. Bye. Follow sober memory. Right there.
Yeah.
Got your paper plate?
I have mine.
Then you do. Right there. You see it?
Oh, a little bit battered, but.
Crushed. Crushing it. Hold on, let's get in there. What is it? Whoa. What does it represent? Here we go. Up there. So say what it represents again.
This represents membership in society on blockchain and AI. And this is like member number,
That's our
logo.
very low value unique
Token.
identifier.
So that's how you do compliance.
Yeah.
It's just as
Adorable
guilty at
media.
that point,
And then we carry the plates around partly because you got your plate, you got it somewhere.
I get it at home.
No,
It's
I'm sure
actually
you do.
framed on my.
We have an audit team in your house now, we don't believe it. Okay, so anyhow, we carry around partly because it's painful, and because we know we don't want them, in fact, we physically can't carry it, right? We take your plates around where they disintegrate, to a photograph, so this will force us to choose a blockchain or some language, some other membership. This closing session of the inaugural MIT Computational Law course back to order, or to order. And I just want to do a quick round robin for any, especially, we've done a little bit of this by way of like, and informal conversations, but projects or like applications of the technology and the kinds of use cases, and those like supply chain is one. Digital identity for disclosures might be another. Any thoughts about that? So we're, as I said, we're actually looking at like them and share them. What I would do is just kind of run a list of ideas at the end. Some of those are perfect, maybe perfect projects or carry forward interest of some people at CEO's office to explore whatever work on at the, actually I'm supposed to announce this in Brian's notes, which is, or work on at the announced just today Computational Law and Blockchain Festival, brought to you by Legal Hackers and a slate of other collaborators, happening on March 16th, 17th, and 18th. You can, and I'll just show the site. Here we are. You can find out all about it at legalhackers.org/CLB Fest 2018. It's Computational Law and Blockchain Festival 2018. That's what that stands for. And it's about learning, hacking, and discussing. So there's something for everybody. And we'll have a node here at the Regional Lab, and there'll be some in DC and New York and all over the place. And if you want to make a node, you just click this form to make one. So if there's not one in the city near you, why don't you fix that? And or talk to people who are willing to. So we can thank again Legal Hackers and all of our partners for that, including with that blockchain diversity group. Weren't they great? So they've been very, very helpful actually on this. And so we hope to have a lot of diversity. But, okay, so so with that in mind, I mean, I know you're eating right now, but are you able to say something about your idea that you've been circulating? Yeah, do you mind?
No, but I don't know.
Okay. Let's see how we shall do this. I want to make sure that your audio is coming through. And actually, I can check 1, 2. Is your my audio? Can you go on mute, Brian?
Yeah, sure.
Check 1, 2. Check 1, 2. Or I'm going to mute you if that's okay.
Yeah.
Or,
Yeah.
I have tried to mute you. I think I can't. I'm sorry, because I didn't start the session. Oops. Check 1, 2. Or actually, you can probably just drop off. Oh, good, you're muted. Great. Okay. Hey, Aura. So you had a very interesting idea, I thought, about a possible use case. Do you want to? Can you share it with us, and maybe just like in like a minute format, and then we'll go around the table.
So
in some religious communities, people keep a type of food habits. So I'm Jewish and I eat kosher. And the whole universe of kashrut, that's the whole industry business of keeping certifications of how kosher the foods are. It's totally based on trust. Right now, certain communities, they go from non-kosher at all to kosher, depending on which rabbis are following. Like go to Israel, but sometimes we have 5 or 6 different steps. And we have like the more broad one is called kosher U. So the letter U instead of a circle, it's an industry type. And it's very often that we trust certain brands are kosher, but then every lot, the rabbis have to come again and do supervision and make sure that the lot is kosher. So for people that really take seriously, we need to keep tracking all the time, some kind of daily basis types of. So I was wondering maybe we can do some type of blockchain application for the whole supply chain. And using the examples that we were discussing before, my thoughts right now are in the sense that someone still has to keep track of the whole league of who are the suppliers involved in certain tracking, certain and enough off-chain basis. Perhaps, I don't know, like.
And sometimes instead of off-chain suggests is almost like a blockchain maximalist view that everything's happening on the chain. I just say it would be like the chain is like off-world, and actually everything's happening on the world in UPS and GitHub and AWS. So it depends on your perspective, but go on.
So those are my thoughts right now.
Okay, so yeah, blockchain for Hillel and Identicon for Providence.
Yeah, for Providence.
Yeah, awesome.
So I did look this up right now. So there's something called Bitcoin,
Yeah, I know.
but it's not for kosher certification.
No, we discussed something called Blackcoin. Some people in the community, I'm involved in this discussion right now. And the whole trust base, the basis right there is like, why do people have efforts to make kind of the industry go to this? If bottom line is people just go after certain rabbis. Yeah.
Okay.
So the application is valid.
Other let's go around. Let's popcorn up just around the table. Just get the ideas out there. I'd say, and I'll list them on the board as we're talking. So, any thoughts, David?
Sure.
Okay. Thanks.
I like the kosher idea. I think that's a really good application. Same supply chain. The supply chain is really interesting, and I also think it's interesting to consider from we talked about this. I don't know how unique this is, but a records management perspective. Authenticating records and tracking records pursuant to records requirements, whether you're a government agency or just another agency or independent organization that wants to have some sort of records program. So,
can I riff off that a little bit? I was thinking about this actually.
But before I just
Sure,
want so it's pause, not stop.
Okay, yeah, sure.
So kosher provenance, would that kind of capture what you're saying? Okay, and just so we can, so provenance, and then how would you say, David?
Records management, data governance, compliance, records compliance, data compliance, and it could apply. You know, the federal government has certain records requirements, but I know that NGOs and other private organizations also have built set up their own records programs as well. And I think I can see how the blockchain technology and automation would provide the type of, as we talked about the first session, provide the type of technology we need to support that.
Great. So if I said records management / governance, would that kind of capture it? Great, thank you.
So
you're saying
to go along those similar lines. So if you have records keeping for like health records, except for you have it for individual soldiers in the field, you can then have every soldier on the ledger, and you can get individuals. So like follow through on that idea. I don't know exactly. I thought about that earlier. So it's like this other idea about unique identifier with get your DNA sequence to your hash, and that's you. That's you forever, right?
Or you could see it applying to the soldiers' records. You can see it applying to just email records, and it's really everywhere.
All right, very much so. I'll bite my tongue on it. There's a lot to say on that one. Great, thank you for sharing it. Any other thoughts or ideas? And by the way, you're not limited to one. If you want to, you have a couple, and if you'd rather take a pass, all legit. Just want to harvest a little bit.
The only thing that I would think of is there would have to be a way for the user or the person who bought the food to verify that stamp or label or whatever is affixed to the product did come from an easily verifiable way, because you might not have access to the technology to research where it came from. I mean, the first thing I think of is probably an app of some sort.
So you go back to the Identifier.
Yeah.
Yep. So I just kind of making a quick note as we go. One of the big, and then we'll come back to this and a lot more on each of these. And this is basically the input sort of discussion we're going to have to close out. But there's a verifiability challenge, which is certain, because it's easy to pump out labels that can postulate any fact pattern you want to lie about. So verifiability back to something that can be proven in fact is key.
I just think it'd be really important for food because you're going to eat in the next few minutes. It's not like a huge shipping bullets that have to auditability.
So different challenges.
Yeah.
Well, let's keep going.
Maybe.
Sure. So we have a lot to say about it. I'd like to get all the ideas out first, and then let's dig in. That's also a pause, not stop. And
it's just to piggyback on the verification. What we're kind of talking about really is a certification of kosher or certification organic. For example, that's another example of what needs to be certified by the government. So, where am I going with this? Really, the records that needs to be verifiable are the inspections.
Yeah. So what I'm doing here, and it's probably what I was thinking, I bring up and others didn't want to discuss the things, is a generalizability thing here to food inspection. There's actually a lot of work in blockchain and from the QR barcode and a whole bunch of other folks for food safety and on down the line. But let me ask you before I let you go, because I know it's tempting to reflect back on ideas that have happened, but have you had any other ideas about maybe this technology could be used for this or that, in addition to records management or food supply chain? And that's the question right now. Is like we bubble up some ideas, and I'm going to go a little bit out of order just to get a few more on the board that I know are right here, and then we can go out of order. Going in a circle is probably the worst way to ask this question, so I apologize. But could you just say again, so I can put on the board, the cool idea you had last night about DNA?
Right. So if you get yourself sequenced, right, and then you assign your hash to that sequence, or you're able to verify that that is my sequence. That's you for. And so your hash is you. You're connected to your DNA. I mean, there's other ways to do the ID too, like we're talking about, like scan and thumbprint or something like that. But I don't know. There's something we said about that. It's I'm a biologist, but
yeah. So if I were to say, like, what about something where we use the DNA, the data, and the hash of that as a verifiable identifier?
Right.
That's it's very interesting.
So there's it's like 80 gigs for your sequence at 30 times sequence. So it's not that bad.
Yeah. That's something that we can imagine verifying pretty quickly on a network, but not on every pack, not on every job response basis.
Right.
Okay, so that's a good one. More ideas, Tammy.
Mine is a lot more simpler, I guess. I wonder, like, how can we tie the identity of, like, a vendor to their, I don't know, whatever identifier they use on the blockchain when a good actually transfers hands. So, like, you're using the identicons to kind of track the supply chain of a good, but then how do you ensure that it actually makes it to the end consumer once the payment's issued? Like what happened with David, he sent someone money, right, on Ethereum, and the guy just never sent the good, and there's no way for him to actually get recourse for that action because, like,
I can look at Block Explorer and show I sent this person something.
Yeah.
That doesn't really, I audited it, but that's not.
It doesn't do you any good. Yeah.
So
So like how would we be able
How to
to,
write this.
yeah.
It's like the first few years you said were good, but then tying
vendor identity to transaction ID.
to a transaction, but not just a transaction like of a spend on a blockchain,
Yes.
but like to like the
Transfer
relevant
goods, yeah.
all the relevant
Yeah.
transactional. Can anyone help me with this?
Better word.
Like some KPIs perhaps, performance indicators for every type of.
I mean, just with a way to encapsulate the core thing in like the form of like 4 words. I'm just gonna go for it if no one helps me now. Okay. Say who's saying what?
So maybe we can help you as you go.
Okay, all right. I'm gonna say. Okay, let me just see if I can refine it a little bit. So, do you mean TMA? Is there a way to? Because you used a example of David's unsuccessful transaction where basically proved that he sent the money, but he didn't receive the goods, nor was there any evidence that he didn't receive the goods. So could it be tying? So like I'm just going to say evidence, but by that we mean sufficient evidence of like key transaction events to and identity together.
Yeah.
Like proven events or something like that. It's much like Donut Tracker that we were discussing.
Right. Yes. So it's something about like key life cycle events,
Yes.
key life cycle,
Yes.
verifiable key life cycle transaction events, or like that.
Sure, milestone.
Milestone,
Yeah.
like a milestone would be. Okay. Can we create? So it's like create.
Transaction milestone.
Verifiable key. I'm sorry.
I said we want to keep key performance indicators. There's like a checklist that people have to complete.
Well,
No,
it's like
but
key
that's a
events
little-
because KPIs
Yeah,
don't
that's a little
necessarily
bit
think of
different.
transaction events. Milestone similar, a bit broader, but they could be anyway. Key, so maybe a bit broader. Key
Transaction.
life cycle,
Yeah, okay.
because that gets down to life cycle transaction events. Luckily, this is being recorded, so we can go back and unpack what that means. But that's good, and we'll come back to it later. But something that Brian and I will probably I'll talk about is like maybe a hack. Actually, I'll put one up right here, which is part of this, which is a hack to incorporate FedEx and UPS API to the what is it like North to the Thomson Reuters blockchain.
Yeah. As an oracle.
Yeah. So it'd be like, so I guess the project that I have in mind, the possible application that would be successful, create verifiable evidence of key life cycle events in a transaction would be, maybe not hack, would be like extend Oracle, ORACLE to, one is going to be UPS and FedEx, and then 2 I'm going to say GitHub API, just because that's an easy place to sandbox stuff. So you change a file, someone makes a commit that's available in API, that can trigger something. Like the code was deposited, something happened that can stand for a while. UPS and FedEx have a few things like goods were shipped, they've made it past a certain point, they were received, the signatures there, so we can do quite a few interesting things to begin to get at, well, exactly David's use case. Okay, good one, thank you, Tiana. More ideas. Ellen.
So I have two. The first one, I think, is the future of computational law. One part of it should become the W3C of blockchain contracts. So that I think that one of the things that I see a lot, and as I do a contract, a smart contract is the same thing as a contract, and it's based on certain primitives that have to be kind of the specification of the code, and that right now, as coders, we are the gods in our world, and we can code whatever we want without taking care of the law. But if we had a number of specifications that we can follow in order to say my code is compliant to the legal system, then that's an advantage and something that basically seek to make the blockchain accepted in the wilder world. So, for example, a buy and sell, like if there was within a product a buy and sell, then instead of having the transaction having to happen or the transfer of funds having to happen first, there should be like kind of a commitment that when you receive when you scan the product that you receive, then automatically from your wallet is going to be deducted a certain amount. And that's how a transaction should happen. And it should be legally described as this is function 1, this is function 2, this is function 3. These are the players, as we did, the actors. And I was hoping that today we could actually get on to that. But that's,
luckily we live in Cambridge, so
yes.
we can't get
but I think that that's like would be like a great tool for coders. And
so how do you
those
like
different
4 or
things.
5, 4, 3, 4 or 5 words?
So specification for smart contract.
Legal specification.
Legal specification for smart contract.
Really good one. Yeah, so this is great. Thank
And
you.
so that you become like kind of, and then like I just want to make one thing also like
Great. You
give the
definitely have
veil on the technology of something that I've heard. Like one of the key ideas to identity is that you only have one identity on the blockchain. It is a universal, transparent blockchain in which you only need to have one identity. And one of the reasons that we might see some of the technologies get so much funding in ICOs, it is most of the time which company is actually going to create the standard that is going to be used across the board by all the other companies. And since it's a contract, it's going to be used much more often than just a transaction. Numbers of companies can do simply as a transaction, but the person who wrote the first contract that's going to be the most used is going to get rewarded every time that contract is used. And therefore, making that
So an incentive structure for good legal instruments?
Yes, I think that that's that kind of.
That's great. I was just talking about how major incentive pizza is hackathon for some of the best innovations come remarkably, out of like the blue in this space. But incentive structure for what, like legal innovation, or what for just in general?
In general, I think like kind of the incentive structure that's going to that it inform certain behavior, right?
Especially for innovation and propagating it. So when a lot of people use your innovation as part of it. So when I say for innovation propagation, I don't know. For innovation.
For innovation.
Okay, here we go. Innovation, like usage.
For participation or for engagement.
Engagement.
For engagement. So yeah.
Okay. All right. What else?
Okay.
Any other ideas or thoughts?
The group done.
Anybody? Anything?
So I like the energy stuff, but so one idea related to our business is, as I was talking about the world check, so we have a centralized group that is looking for enough consensus public records to say this person committed a financial crime or this person was acquitted, and so on. You could distribute that instead. So instead of paying all these people to find enough evidence to say you're on or off this ledger of criminals, we could just distribute the gathering of that information, and if there's enough consensus by all of the people who are, rewarded for adding records to the blockchain, then once you get sufficient agreement that so-and-so was acquitted, then you're off, or convicted, you're on.
So there's, I'm hearing two kind of things about, so for the thing that we'd be innovating is the list of, what kind of wrongdoers was it again?
Well, financial criminals.
Financial criminals on, what was the Thomson Reuters list?
It's called World Check.
World Check, okay, so on World Check. So could there be a distributed, like quasi crowdsourced method, or two sort of things you said? Number one, like almost investigative, like when people discover things, could they offer them? And number two, the main thing is fact check and have consensus on whether the person belongs on the list or not. Like is something been expunged and been acquitted? Was it whatever?
Right. So it's basically consensus about does the public record indicate this or not?
Consensus on on basically world check, status.
Like a decentralized background check, that you should have different sources
Well,
providing
good point.
inputs.
Decent.
Yeah, I guess it is like a background check, sure.
If I said crowdsource, would that be good?
Yeah.
Because crowdsource lets us avoid this sort of conundrum, decentralized and distributed and some of the other. Okay, that's a good hack that we should talk. Let's keep that alive and talk about that. And that would be useful too, especially when you have innocent parties that are not on there. You're doing, world check as a service, but it's hard to police the whole thing. So this is good. The idea of being able to get off of the list when a lot of people are aware that you shouldn't be on it, but it's hard to staff to the level. That's very interesting. Any other thoughts you have?
Well, I really like the energy stuff, but
What do you like about it? An arrow coming on.
It's well, I mean, I think all of the virtues of it were pretty well explained yesterday, but monitoring of public goods, distribution, the ability for people to write their own contracts about how they're going to participating in this system. It's all pretty fascinating. And the fact that the blockchain seems like a good way to manage a lot of this stuff.
So it's almost like, let's just do it. I agree. I think we should do it. And Michael's a terrific partner to do it with. He's got a live idea and a head of steam and places to drive things. So, like energy systems automation of the legal governance functions. And that is like, most people here don't claim to be legal. So like there's an open space there in that project.
Yeah.
So thanks for kind of like verifying that during the wrap up. I think it would have been incomplete on the list without that. Okay. Any other thoughts?
It's probably off base. But along the same lines of the world check status list of companies, what about the scaling it down to the medical record of an individual, where that patient may have seen multiple doctors from various hospitals, and there's a need for all the caregivers or the attending physicians to have visibility of the treatments that this one patient's had. So is there any way to verify the individual treatments for that patient? And house the record on the blockchain. So there's.
Well, you want to house like something at a government center, right? Like have,
The goal is to ensure that all the doctors that are treating this patient have the same visibility of the treatments that's been done by the various doctors, to ensure that there's no.
Yeah.
I worked for a healthcare company that did, so where their goal is a startup.
Just FYI, I would say, like, let's say that that idea has launched us into full-on discussions. So if we could do 10, I don't know if anyone understands the plane, but can we do 5? If we can't do 5 minutes of open discussion, that's okay. Then just sort of surfacing these is good. But let me do a quick time check. Do we need to wrap right now, or how many minutes of discussion? And assume it'll take 5 minutes to get your stuff in the back and get out.
Well, we have 10 minutes before we have to.
Okay, so how about 5 minutes of discussion and then a hard wrap and then 5 minutes of like.
Buys and hugs.
Sound good? Who's the timekeeper?
I'll keep time.
Thank you, Timmy. All right, Ilan, I'm sorry to interrupt you.
No, it was like kind of saying one of the issue that was like kind of that's always really interesting with blockchain technology, like the medical records, because so I was working on a startup that was doing that without blockchain, and one of the biggest hurdle is getting all the players to buy in, and so the proposition, and that's why you see, it's like a banking system. Is there going to be a consortium of the players in the healthcare industry to actually enable this to happen? It could happen anytime, but they just don't want it.
Well, that's interesting that you say that, because the Department of Defense and Veterans Affairs has a project ongoing right now where they're actually sharing health records of retired, separated, active duty, airmen, soldiers, Marines, military members. But the way that it happens, the Congress has the law required it because they couldn't get exact buy-in. So from the law, then the two departments had to cooperate and talk to each other and come up with a mechanism to make it happen.
Yeah.
What do you remember if we want to learn more about that, where would we look for?
You can Google VA, DOD, medical health records, and it'll come up. I just always follow
That-
it on top.
That's good. I just want to. That's exactly what I was looking for. And may I ask?
I just want to also say on the energy blockchain, I was researching, and it appears that Australia has sponsored a similar project already using blockchain in the energy sector.
Fascinating. Okay, I did not know that. And perhaps Michael does. We should ask him about that because if it's happening, then we should find out how they manage the legal aspects and maybe get some ideas.
Also,
Common law nation as well, English speaking.
also the initiative of Australian standards, it's another website. But
Yeah.
I was talking about the standard.
Yeah.
We also have
So on the, I guess the final thing on the medical thing, before we lose it, is Blue Button. You know Blue Button? Is there anyone? Do you know Blue Button? Okay, Blue Button is a triumph of the United States, I think, and it should be a model for the world and for every other sector outside of the military. But when you leave the military, military service in the United States, since it was early in the Obama administration, during that time I was mentioning of open data and data export and liberation standards, and I think that Novak was involved in others, and you can now hit something called the Blue Button, and it goes through all the medical records across all the different bases and kind of physicians and agencies and everything else, and it puts it into a standard big file, and it will export to you, and you can kind of even say a little bit, I think, about routing, like sort of like onto the desktop, or will it put it somewhere where I can download it with a link, and there's a little bit of that there. That is awesome. So at least at some point you can get the whole thing and then take it from there. It doesn't quite answer the question that you're, I think, getting at, which is ongoing medical record and personal health record, online coordinated access control and updating and all of that stuff, which is obviously a very, very big issue.
And that would be outside. So you have private practitioners who are challenged on a daily basis to help they'll see a patient for the first time, the patient may be resolved, and they don't have immediate access to their records, and the patient's not going to be able to, and oftentimes provide them the pertinent data that the provider needs.
Just so, yeah. So there is actually something in the media lab called Health Rec, is it, or MedRec, which is a very successful project that was done partly in the digital currency initiative by a media lab student to basically hash certain aspects of the records in a somewhat in a standard way and make an entry on a blockchain, at least to get the provenance part. And they did a few other things. So if you search MedRec, you can see an innovative solution that was, I can't remember who it is, like whoever the main medical record health coordinator is in HHS. It was presented to them in something, and they got some pretty good feedback. And I worked on it in a hackathon in Nashville one time, and it's interesting. So one of the problems you get when you try to have medical records that are in authoritative places, especially if they're something where you'd think they were attached to the person and that we'd have them in a Dropbox or a thumb drive, is that practitioners, for lots of reasons, clinical reasons and liability reasons, are very reluctant to rely upon the records coming from a patient, which would be the natural network centroid for all the records, because are they accurate? Are they up to date? Are they true? Have they been hacked? And all sorts of things. Like, do they want to not have people think they're that fat or whatever it is? All these things that people do and all the things that happen in reality. And who's left holding the bag? Like, what does it mean for your malpractice premium when you're doing this, and for standards of care? So this MedRec thing, among other things, from a legal perspective, maybe this component, of having a hash of the records from the clinician and from the source of the clinician, so some identity stuff. Getting to what you were saying in commerce, if you apply it to this is the clinician, this is the record, this is the date that we got, and you get a kitty cat on there, or an Identicon or something, and now you collect these things in a personal health record. Perhaps then we could move the centroid for individual health records to the person themselves, but also have faith in the accuracy and the up-to-dateness and the source of those records. potentially. But I think there's a lot more work to be done on that one. I'm glad it's on the board. So it looks like I'm sorry, it's not done, but unfortunately, I think we've come to the point where the computational law course is over. And so I want to just thank everybody for bringing, I really feel like everyone brought our A game to this, and I consider it a very good start, for which I'm grateful. And I'd like to invite everybody to remain in contact through Telegram, but also just through normal channels of like email and our web. We do a lot of things online with Hangout. You can, somewhere like outside of your skiff, we can do Hangouts or your lives. That is always good. And also you're certainly welcome back. Welcome back to the Media Labs for those of you who are local and those of you who come from further away. Let's consider this a very good start, and I hope to see everybody in one way or another at the Computational Law and Blockchain Festival, whether you're discussing things, hacking things, or learning, or perhaps teaching. So with that, thank you very much, and let us consider this first class adjourned.